خب شروع کنیم. سلام به همه دوستان در اینستاگرام کانون معماران. ما لکچر ششممون رو شروع میکنیم از مجموعه لکچرهای معماری معاصر از ماده تا انتزاع و مهمون امروزمون امین طاها هست از دفتر گروپ ورک. اجازه بدین که من ایشون رو به انگلیسی معرفی کنم. طبق روال معمول من ترجمه میکنم صحبت ایشون رو لکچر اسلاید به اسلاید و پیش میریم. Okay, hi everyone. Welcome to our sixth lecture from our lecture series, 2022 lecture series, Contemporary Architecture Between Terrestriality and Transcendence. Today we are honored to have Amin Taha from Group Work joining us, and we are very excited to listen to his lecture. Amin was born in Berlin and he has been settled in the UK since 1974. He began an independent studio in 2003 and incorporated Group Work as an employee ownership trust of which he currently sits as chairman. As well as running the design and detailing of projects, Amin has taught, written and lectured on architecture, sat on the RIBA National and International Award Jury, and 8 property-related research groups and funds. The practice has international recognition for its built work, including multiple RIBA National Awards, RIBA Sterling Prize 2017 shortlist, and 2 EU Mies Award 2019 nominations. Their projects have been published globally by the Architectural Review, Architecture Today, iFocus, AIT Magazine, L'Architecture d'aujourd'hui, Blueprint, Wallpaper, The Guardian, and the Financial Times. امین طاها در برلین متولد شده و از سال 1974 در لندن اقامت داره. در بریتانیا استودیو مستقل خودش رو در سال 2003 شروع کرد و بعداً اسمش رو تغییر داد به گروپ ورک که یک جور صندوق مالکیت مشترک کارکنان هستش این دفتر و در حال حاضر خودش به عنوان رئیس این مجموعه هستش. علاوه بر اجرای طراحی و جزئیات در پروژه ها، امین در زمینه معماری تدریس و سخنرانی میکنه. در هیئت داوران جوایز ملی و بین‌المللی ریبا حضور داشته و به گروه ها و صندوق های مرتبط با تحقیق در مورد مسئله مالکیت کمک میکنه. دفتر گروپ ورک برای کارهای ساخته شدهش جوایز متعدد بین‌المللی و ملی گرفته در انگلیس، از جایزه ریبا تا حضور در فهرست نهایی جایزه استرلینگ و 2 نامزدی جایزه اتحادیه اروپای میس در 2019 و همینطور در نشریات متعددی مثل معماری فردا، معماری امروز، آرکیتکچر ریویو، گاردین، والپیپر، بلوپرینت، فاینانشال تایمز و غیره کارشون چاپ شده. So since I was planning this lecture series and thinking about its theme, architecture between terrestriality and transcendence, Amin's work, especially his famous project 15 Clerkenwell Close, was a critical inspiration for me. I briefly visited this building 3 years ago when it was a hot topic on the news after a court in London called for its demolition due to its unconventional use of stone facade, which also acts as the structure of the building. A few months later, I was happy to hear that Amin's appeal was finally approved and the court removed the order for its demolition. Okay, let me translate in Farsi, please. از وقتی که من داشتم برای این لکچر سریز برنامه‌ریزی می‌کردم، همیشه کارهای امین از کارهایی بوده که خیلی کمکم کرد این به تم این برنامه فکر کنم و این پروژه که از اون پروژه ها بود که می‌بینید از تقریباً سنگ رو مستقیم از معدن با کمترین دخالت میارن و در یک حالت خیلی اولیه استفاده کردن در این نمای ساختمون که خیلی سر و صدا کرد در لندن و حتی به خاطر این که گفتن این کدهای ساختمانی رو از نظر نما و زیبایی نما در اون بافت تاریخی لندن رعایت نمیکنه، حتی یک دادگاهی دستور به تخریبش داد و این حتی فقط نما هم نیست، چون سازه ساختمون هم هستن این سنگ ها. بنابراین وقتی می‌خواستیم اینا رو جمع کنیم باید کل ساختمون رو جمع کردیم و خب 3 سال پیش بالاخره اعتراض به این حکم موفق شد و قرار شد که تخریب نشه این ساختمون و پا بر جا بمونه. Revisiting the theme of our lecture series where we have juxtaposed the 2 notions of formal matter and material form, I can detect a similar dialectical relationship in Amin's work. Now, Perhaps extending this concept to a diagram of form and materiality, from terrestrial matter to transcendent materiality, and from what we call a real form to ideal or Platonic form. Perhaps we could locate Barrett's groove on the top left corner, where the building is made of load-bearing bricks to create a symbolic or transcendent form. To the bottom left corner, 15 Clerkenwell Close building, where the project is on the right, which the building is shaped by assembling massive load-bearing limestone pieces representing almost a primitive image. To the bottom right corner, the Upper Street building, where the facade has gone through a digital design process but materialized in a haptic matter, indexing history and classical orders. And finally, on the top right corner is the Ada Street building with an ideal pure, maybe geometry rendered in an unadorned and abstract material palette. Okay, and the translation quickly. من در واقع آنالیز کارهایشون رو تو این دیاگرام به این شکل انجام دادم که کارهایی که میبینید سمت چپ بالا کاریه که یک فرم کلی یک جورای افلاطونی و سمبولیک داره که با مصالح آجر باربر ساخته شده. پایین سمت چپ همون پروژه‌ای که مشاهده کردین، در واقع فرم کلی ساختمون از چیدن روی هم چیدن این قطعات سنگ خام، تقریبا خام به نوعی شکل گرفته. سمت راست پروژه‌ایه که بازسازی یک پروژه تاریخی با استفاده از ابزارهای دیجیتال و طراحی و ابزار کاملا دیجیتال بوده، ولی مصالح کاملا زمینی و پرکست شده این نما. و در نهایت پروژه سمت راست بالا پروژه‌ای که هم فرم و هم مصالح یک تصویر ابسترکت رو تقریبا به ما میده. Considering Amin's practice of architecture over the past 20 years, we see a general transition from what we could call a digital or sometimes parametric design using lightweight elements and porous screens to an almost archaic, prehistoric, and occasionally classical language and a strong expression of materiality. I'm curious to learn more about this transition, perhaps in our Q&A section after his lecture. But now I invite you all to join me in welcoming Amin Taha. Amin, the screen is yours, please. Welcome.
I'm on mute. Yeah, hello. That was a very, very good introduction. I especially like your graph. As you say, we can expand on that. I'm going to start off with Barrett's Grove, where you started. If I can work out how to do full screen. Is that good enough?
Yeah, it's good, but if we can full screen, it's even better. I see there's on the right top, next to the setting, there is the full screen button, I think.
On the right?
On the right, next to the setting wheel.
The setting wheel. Oh, yeah. I see. Yeah, well done. Well spotted. Thank you. Okay, Barrett's Grove is a part of London, which in one generation went from mostly open fields to heavy urbanization. So this is across the late 18th and mid 19th century. At that time, most of it would have been pattern book architecture, where the builders would have been using the brick as the finish, the external finish, but also as the superstructure holding up the building.
اول تشکر کردن و گفتن که این مقدمه و دیاگرام براشون جالب بوده و بعد با این پروژه شروع کردن، با هم پروژه آجری که دیدیم در مقدمه هم در یک منطقه قرار گرفته که قبلا زمین‌های کشاورزی بوده و بعد به سرعت به شدت صنعتی میشه و در دوره بوده که ساختمان‌ها با آجر ساخته می‌شدن، آجری که هم پترن و نمای ساختمان بوده و هم سازه و استراکچرش.
Our request by the local conservation department was please carry on using the local red brick. Now, we can't use brick as external superstructure anymore because we need a thermal envelope. to separate the transition of weather coming in and keeping the heat in.
چیزی که ازشون خواسته بودن در این پروژه این بود که اون نمای آجری این خیابون رو و این منطقه تاریخی رو حفظ کنن، ولی همونطور که میدونید احتمالاً ما امروزه آجر رو نمیتونیم همینجوری به صورت لخت به عنوان نما و سازه هم استفاده کنیم به دلیل مسئله عایق ساختمون و اینکه باید یک فاصله‌ای باشه بین نمای بیرونی و متریال داخل ساختمون.
So architects tend to do, and no doubt that's common all over the world today, is make very lovely, pretty drawings of the outside of a building. And it could be in lovely red brick, as we were encouraged to do. And then hand this to a structural engineer to tell us this year concrete is cheaper or steel is cheaper. I will make a steel or concrete frame and hang my brick facade off that with all its separate, the necessary technology to keep it thermally separate. So that is shelf angles, wind posts, thermal bridging details, weep holes to make sure that any rain that does go through the brick is sent out, and all the rest of it. And the problem of then hanging that material from the superstructure and its differential expansion. So all sorts of technical problems arise from our modern desire to have an image that's then engineered by somebody else, held by that engineering.
و خب کاری که اغلب معمارا امروز میکنن و خیلی پذیرفته شده است انگار خیلی جاها اینه که میان یک نمای آجر قرمز هر شکلی که دوست دارن طراحی میکنن و بعد این ساختمون رو میدن دست مهندس سازه و میگن شما تصمیم بگیرید این سازش چی میتونه باشه، این میتونه کدوم ارزون تره، امسال بتون ارزون تره یا فولاد ارزون تره و کاملا میان جدا میکنن این مسئله نمای ساختمون و تمام جزئیاتی که داره در مورد عایق، در مورد آبچکون و غیره و نما تبدیل به یک عکس برگردون میشه و یک تصویر فقط میخوان ازش بسازن از این آجر رو.
Why is this a problem? And you might be thinking, well, who cares as long as it looks how I want it to look. But you might ask yourself, is there an ethical reason why I should be thinking more carefully how the architecture, just like the predecessors, where superstructure, engineering, and architecture became one, is there a way today I can do the same, and why should I? Well, the ethical reason might be that it's cheaper for the client to do so, that it's greener, more sustainable to do so.
و ممکنه شما این سوال کنین که کی اهمیت میده؟ چرا اصلا مهمه که ما مثل قدیم ساختمونمون نماش واقعا نمای باربر باشه و این فقط نمای مصنوعی آجری رو ساختمون باشه؟ به نظر من این دلایل اخلاقی داره این تصمیم و دلیلش اینه که اولا وقتی که این اتفاق میفته ساختمون ارزان‌تر در میاد، دوما ساختمون سبزتره و پایدارتر از لحاظ زیست محیطی، ضررش کمتره وقتی که این مسائل نما و سازه یکی میشه.
So our decision was to say, if the external finish cannot be the superstructure anymore, it has to be separated from the structure, then can we make that superstructure of something where just by itself is not just holding up the building, but also the internal finish. So we don't need to add extra layers of plastering and plasterboard and aluminium sheeting and all the rest of it. Now, why do that? Well, because it means the superstructure, in this case, cross-laminated timber, only needs to be half the size and therefore half the cost and half the material. If the brick is allowed to stand up on its own, it's not suspended from the superstructure and allowed to move independently.
و حالا امروزه ما میدونیم که پس این ساختمون مثل ساختمان قدیمی نمیتونه کلاً با آجر سر پا وایسته به دلایلی که گفتن و نمیتونه به عنوان سازه کلی یا سوپر استراکچر ساختمون عمل کنه این آجر. پس حالا ما چیکار میتونیم بکنیم؟ حداقل اینه که نما وزن خودش رو تحمل کنه، یعنی نما سازه خودش باشه و داخل ما یک سازه جدای CLT یا چوب مهندسی شده کراس لامینیتد تیمبر داشته باشیم و این دوتا از هم جدا باشن. چرا این چه اهمیتی داره؟ چه مزیتی داره؟ مزیتش اینه که سایز ضخامت و قطعات CLT تقریبا نصف میشه. به این دلیل که دیگه این CLT داخل ساختمون نیاز نداره که باربر باشه، وزن نما رو هم روی خودش علاوه بر وزن ساختمون تحمل کنه و در نتیجه سایز قطعات کم میشه و ساختمون ارزان‌تر بشه.
So the CLT here is all the floors, all the walls, all the roof structure, and the brick is just an overcoat after the insulation. And this is the detail. CLT becomes superstructure, internal finishes, the insulation on the outside with its water barriers, vapor barriers, and then the brick is a self-supporting skin, allowing independent movement. Altogether, this brings the cost down by 25% of the overall construction.
بنابراین این CLT یا مصالح چوب میشه سازه داخل ساختمون و همینطور فینیش داخل ساختمون، مساله‌ای که ما از داخل میبینیم. بعد ما این رو از یک لایه عایق میکنیم و بیرون اون این آجر باربر رو داریم، آجری که در واقع وزن خودش رو داره تحمل میکنه و همه اینا باعث میشه که هزینه این ساختمون 25% در مجموع کاهش پیدا کنه.
So internally, it means that you're looking at the timber as superstructure, but also your finish.
و در داخل ما این CLT یا تیمبر رو به عنوان هم سازه می‌بینیم و هم پرداخت نهایی، مصالح نهایی داخلی.
On the left-hand side is the standard model, economic model for construction in this country, so the private sector. The red 25% profit is what the bank will call their risk money. There's a risk that this project might go wrong, but we don't expect it to go wrong more than 25%, so the project will not be in negative equity. And the rest is divided between construction costs, which includes all the consultant fees as well as the material and construction, and then the land value.
ما تو این دو تا چارت سمت چپی وضعیت استاندارد عادی رو می‌بینیم. وقتی که بانک در واقع وام رو میده برای ساخت ساختمون، یک بخشش میره به قیمت زمین، یک بخشش میره به هزینه ساختمان و یک بخشش 25% هم برای ریسک نگه میدارن که اگه اتفاقی بیفته و یک اشکالی تو ساختمون پیش بیاد ضرر نکنن و اون رو برای شرط احتیاط داشته باشن.
Now, on the right-hand side, because we dropped the construction cost by 25%, it effectively means the profit increases by about 10%. Now, in the public sector, so if we're doing public housing, affordable housing, it's termed in this country, it means that what you have done allows that affordable housing provider to get a new building for free for every 4 they build, against the equivalent had they maintained traditional construction methods of concrete or steel frames.
و در واقع این به این معنیه که ما داریم با اون 25% که کلا کاهش پیدا میکنه هزینه ساختمون که گفتم به خاطر نوع استفاده مصالح، باعث میشه که در مجموع 10% سود مازاد داشته باشه این کانستراکشن و این اهمیتش در پروژه های مسکن ارزان یا افوردبل هاوزینگ مشخص میشه که انگار ما داریم خونه های مجانی اضافه میکنیم به پروژه ها و باعث افزایش بهره وری میشه.
Now, the lesson that I'm expressing here for Barrett's Grove is the ability to critically think of your materials for structural as well as your architectural reasons with a framework, an ethical framework, depending on who your client is and what they're after.
و چیزی که درسی که ما داریم از این پروژه میگیریم بحث اخلاقی این قضیه است و اینکه چطور توی پروژه مختلفی میتونه اهمیت پیدا کنه بسته به اینکه کارفرمای شما کی میتونه باشه.
Now, the difficulty is in the private sector. If you hypothetically, what we've actually done is increase the land value, because if you maintain construction costs less by 25%, the bank will only be interested in 25% return, and therefore it's the land value that increases. So hypothetically, on the right-hand side, as architects, we could be reducing the construction costs next to zero, and really all you're doing is increasing land value for the public sector. So it's an important lesson for the public sector not for the private sector, because in the private sector you're just increasing land value and not providing more homes or more affordable homes.
و این یه تفاوتی بین در واقع پروژه دولتی و پروژه خصوصی و شخصی هست. در پروژه خصوصی وقتی که شما این هزینه ساخت رو کاهش میدین، فقط انگار که اون ارزش زمین داره بالا میره و اون 25% سوده تغییری نمیکنه، پروفیتی که نگه میداره بانک. ولی در پروژه های عمومی و دولتی مسکن جمعی ارزان به این معنیه که شما با کاهش قیمت ساخت میتونید تعداد واحدهای ارزون قیمتتون رو افزایش بدید.
Okay, this is a project with a Bayswater Road. Some of you will know there's on the top you can see Hyde Park, Kensington Gardens. That red dot is our site in Queensway, Bayswater.
و تو این تصویر محل سایت پروژه رو می‌بینین، بالای هاید پارک هستش، سمت چپ بالا جایی که قرمز شده.
It's one of the last sites where the end of the urban block is made up of smaller collection of buildings and therefore offers an opportunity for a mansion house.
یکی از تنها نقاطی از شهر باقی مونده که ساختمان‌های به این ابعاد ساخته میشه در اینجا. و
one of the exercises we do at the same time as arranging plans, floor plans in a traditional way, as every architect does, is investigate the context, and that context might be a social context. In this case, some of the buildings have an interesting history. This particular one is quite richly decorated and made of quite good materials, very rare for the area, and it's directly adjacent to our site, and it actually turns out to be the house for the Prince of Wales at the time, and his mistress, who was Lily Langtry, a famous actress at that time.
و ما حالا برای قسمت مطالعه پروژه سعی می‌کنیم کانتکست پروژه و تاریخش رو به خوبی مطالعه کنیم و ببینیم که چه جنبه‌های اجتماعی تاریخی داشته. و این ساختمانی که دقیقاً بغل سایت ما قرار داره، همسایه‌مون هست، یک ساختمانی با دکوریشن حسابی زیاد بوده که معلومه ساختمان گرون و اشرافیه و متوجه شدیم این ساختمان متعلق به پرنس ویلز در اون زمان و همسرش هست که یک بازیگر بوده.
The two gentlemen at the bottom are well-known architects of that time, Muse and Davis, who are like the Norman Foster today, who built the Ritz Hotel, the RIC Club, various country houses, and large hotels in central London.
این دو نفری که پایین می‌بینید معمارای پروژه بودن که مثل نورمن فاستر زمان ما هستن، در زمان خودشون بودن.
If you go to this building is now a hotel, and evidence of its history is still on the ground floor. It's a listed building, and you can see there a sort of very small theatre that's now a hotel restaurant, which would have been where Lily Langtry would have performed, and the Prince of Wales would have sat on the left-hand side.
اگه به اینجا برین الان یک هتل رستورانی قرار داره تو این ساختمون که جایی که اون خانم قبلا اجرا می‌کرده در این فضا.
This is not to say that every project, when we do this research, is influenced directly by our neighbors, but it's material that orbits our mind while we're investigating straightforward context, and that context might be, in this case, directly looking onto the park, facing south, so lots and lots of noise from the traffic, privacy issues because people are looking directly into these residential windows. Overheating because you've got sun all day, especially in the summer. So while we're dealing with these issues, including planning issues about how you lay out your plans against traffic and privacy at the background, these ideas might be orbiting your mind.
به هر حال ما هم تو همه پروژه‌ها پیش نمیاد که ساختمان‌های همسایه رو مقایسه کنیم، ولی این یک مورد خیلی خاص بوده با یک تاریخ مشخص و علاوه بر این تاریخ ما باید هزار تا مسئله مثل شلوغی اونجا که اون منطقه که چسبیده به پارک هست، سر و صدا، ترافیک، بحث حرارت و همه اینا رو بررسی می‌کنیم در کنار کانتکست هست.
while we were doing with the environmental issues, we realized we needed a heavy set of louvers to keep the sun away. The louvers might allow privacy shut, to allow privacy for the residents when buses and traffic and tourists are passing by on that road. And while we were developing that idea in a much more traditional way, it occurred to one of us who was experimenting with the idea that Muse Davis, these architects of the last century, turn of the 19th and early 20th century, had they had the opportunity to finish the urban block, because they did one corner of it, like they had done at the Ritz, what would that look like? And it was just a fleeting overlay of two ideas of dealing with environmental privacy and other issues with this false history, this false narrative of the past, that then allowed that to become the Louvre system, as it were. So a veil, an illusion, a mirage that from a distance. So technically, you carry on while I go through these slides.
Okay. و ما دو تا ایده را همزمان در ذهن داشتیم. از یه طرف بحث پایداری بود و اینکه بتونیم از این لوورها، از این نما، از این شیدر استفاده کنیم برای محافظت در برابر گرما، ولی در این حال این اون قطعه‌ای بوده که این معمارایی که معرفی کردم بهتون، میوز و دیویس، نتونسته بودن تمام کنن تو این اربن بلاک و خالی مونده بود و داشتیم به این فکر می‌کردیم که اگه اینا می‌خواستن کامل کنن این بلاک رو و اون رو هم بسازن، اون چه شکلی می‌بود. و کلا این اسکرینا هم برای ما دارن اون یک جورایی ایلوژن معماری اونها رو درست میکنن و اون تصویر رو بازنمایی میکنن و هم بحث زیست محیطی دارن.
So from a distance from the park, it might appear as if it's an older building made of stone, and as you get closer you realize some of the facade elements have shifted, adjusted, whether it's for clear views out or keeping the sun out. And at night, obviously, the light comes through it. And as you get closer and closer, you realize it's not solid at all, but actually an illusion of 3 millimeters of brass.
و ما این از دور که این ساختمان رو می‌بینیم فکر می‌کنیم یک ساختمان سنگی کلاسیک معمولی هست. یک کم که میایم جلو می‌بینیم فکر می‌کنیم این قطعات یکم جابجا شدن و بعد که واقعا نزدیک میشیم یا در شب وقتی نور عبور می‌کنه از این اسکرین، از این صفحه نازک، از این دیوار پرده مانند، می‌بینیم که اصلا این سنگ نیست، یک متریال نازک فلزیه.
The next project develops that theme in a similar way. This was a competition in central London as well, where one side of this otherwise intact terrace had been bombed in the Second World War and stayed empty.
و در پروژه دیگه ما این ایده رو دنبال میکنیم. یک پروژه بود که مسابقه بود و یک بخشی از این ساختمون توی جنگ بمبارون شده بود و خالی مونده بود.
And we were given 2 weeks with other competitors to come up with some ideas, and we thought, well, why not rebuild literally the building that had been bombed, just for the purposes of getting us across the threshold of winning the competition, but as a memorial to that, so as a monument to that had been bombed and had vanished.
و ما به این فکر کردیم که چرا نیایم و این تیکه رو پر کنیم با همون چیزی که قبلا booده به عنوان یک یادمان یا یادبود اون چیزی که اونجا بوده و این ایده رو دادیم.
Which, because we'd been thinking from the Bayswater project, this idea of false histories, and we'd recognized very quickly how it was received by other people who seemed to desire the old-looking buildings and this feeling of nostalgia for things that are old, of not of their generation, of clearly of the past. And it's that analysis of that nostalgia that we found interesting, because ultimately it isn't our generation, it isn't our period, but we clearly strip it of uncomfortable ideas of that period, and just imbue it with some sort of nostalgia and positive elements only.
و ما در واقع کانسپت همونیه که تو پروژه قبلی بود، این که ما هم علاقه به این نوستالژی داریم و این تصویر تاریخی این ساختمان‌ها که اونجا وجود دارن، ولی در این حال با این استراتژی میایم و اونا رو از ماده خالی میکنیم و یک بازنمای جدیدی از اونا نشون میدیم که یک جور فالس هیستوری میسازه، یک جور تاریخ غلط درست میکنه، یک بازنمای تاریخی غلط عمدی.
So here we treated it as if it was a monument, a cast monument. So if you look carefully, the red material is a cast in situ cast terracotta cement mix, which is actually a twin wall, structural twin wall tied together. It is hollow. It is a hollow carapace monument that rises up as a structural wall, becomes a roof, and comes back down again. The interior is entirely timber and has no relationship in terms of its floor levels with the original building. It is to contemporary floor levels. So all the interior materials are timber and softer and take up their own occupation. This is then manifest by punching through from the inside outwards where you want a window, where you desire your perfect sized window for a bedroom or a living room.
نمای بیرونی مصالحش قالبگیریش از قالبگیری تراکوتا، یک جور مصالح سفالی ماننده و سیمان، ترکیب این دوتا درست شده که تو خالیه ولی در این حال وزن خودش رو تحمل میکنه و از روی نما میره بالا و روی سقف بسته میشه. در داخل ولی ما کلا از تیمبر یا از چوب مهندسی شده استفاده کردیم برای سازه داخلی و فضاها کاملا متفاوته از اون چیزی که رو نما میبینیم و اون فضای داخله که داره اوپنینگ ها و پنجره ها رو به ما تحمیل میکنه. در واقع ما از داخل میبینیم کجا نیاز به گشودگی و پنجره داریم و همونجا مستقیم روی نما حفره ایجاد میشه و این فاصله که بین جای پنجره ها رو نما هست با جایی که پنجره های واقعی هستن رو توضیح میده.
And the reason we chose the in situ materials, because most of you will know if you work with pouring concrete, for instance, into molds, it doesn't want to be perfect. It always has flaws in it. And we spend a long time trying to make the concrete or in situ casting look perfect. We thought if we choose a material that is going to be imperfect from the first day, it speaks of the imperfection of this memory, of our idealized misremembering of that past, creating a monument, an idealized monument that's been stripped of things that are anomalous to our ideals.
و خب همونطور که گفتم ما این مساله رو در محل قرار بود که بریزیم، مثل بتون که ریخته میشه و میدونید در چنین شرایطی نمیشه کیفیت رو کنترل کرد و نمیشه یک وقته نمیشه قطعه پرفکتاشون وقتی ریخته بشه با تمام نواقصش دیگه اونجاست. و اتفاقا این کانسپت به ما کمک میکرد با این بحث تاریخی که داریم و این یک جورایی اون ایمپرفکشن یا عدم کامل بودن یا نقص تاریخ رو، اون نگاه انتقادی رو که داریم بهش منتقل میکنن، این ایمپرفکت بودن مسائل.
This is a technical detail of showing you how the casting is internal and external. So when you're within, you also have a feeling for what used to exist in the past, and then this new structure attached to it.
و توی این مقطع شما میبینید که به چه صورت این مساله ما هم در داخل اینو میتونیم لمس کنیم و ببینیمش و هم در بیرون وسطش یک حفره است که عایق قرار داره.
And then the building as it is today. What we, in addition to allowing the material to do its own inevitable failure, so that's just in its finish, expressing the sense that our memories are flawed. We also allowed some of the pieces of formwork to be cast upside down or even removed from an upper floor, taken to a lower floor.
و وقتی که کامل شده شما این نواقصی که گفتم رو میبینیم. ما خیلی از این قالب ها رو اجازه دادیم جای اشتباهی باشن یا برعکس باشن و فینیششون تمیز نباشه، به همین دلیل که این دیدگاه انتقادی ما به قضیه حافظه است و اینکه ما یک چیزایی رو درست به یاد نداریم یا از تاریخ و حتی حافظه غلط داریم.
So the interior also had period wallpaper pasted onto the formwork before the casting occurred to then express that period, as it were.
و در داخل اون کاغذ زیبایی رو می‌بینید که توی قالب این قطعات گذاشته شده و یک جورایی چسبیده شده در خورد این مصالح رفته برای اینکه اون دوره تاریخی رو ما بازنمایی کنیم، دکوریشنش.
And then the occupation is obviously on different floor levels from the original, and therefore the cutting through has got no relationship with the old window lines.
این فاصله بین اون اتفاقی که در داخل میفته و بیرون ساختمون رو اینجا تو این تصاویر مشاهده میکنیم.
This is a metro station in Sofia in Bulgaria. We won in competition. There's a new master plan on the edge of the city that's meant to be part residential, commercial, and needs to integrate a metro station, bus station, so it's an interchange, but also a green park that links to the other parks in the city.
این پروژه یک مسابقه هست در شهر سوفیا در کشور بلغارستان که ما برنده شدیم و پروژه ایستگاه مترو هستش در محله‌ای که هم مسکونی و هم تجاریه و این مترو در کنار این مترو استیشن در کنار یک پارک هم قرار گرفته که تو این محل قرار داره.
There are two ways of building metro stations and underground lines. One is tunneling and the other one is cut and fill. This is a cut and fill method. So you cut a trench, you build your station and rail line, and then you put a lid back on top. Now the problem with that is while you've cut your trench, you've got to stop the walls collapsing in. So you put temporary structure in between to stop the walls collapsing in, put a lid on top, and then you take your temporary structure out. That temporary structure on projects like this can be up to 30% of the overall costs.
دو تا متد کلی برای درست کردن این ایستگاه قطار وجود داره. یه متد تونل درست کردن هست و متد دوم اینه که شما این زمین رو خالی کنید، حفره خالی کنید، ساختمون رو در واقع اون پوسته رو بسازید و روش رو پر کنید بعدن. و تو این متد دوم که ما ازش ما استفاده کردیم، شما یک سری سازه موقتی داریم برای اینکه کلاپس نکنه دیواراش و این سازه موقتی که ساخته میشن در اینجا حدود 30% هزینه کل ساخت ساختمون رو شامل میشه.
So here with our structural engineer, civils engineer, we suggested that the piling occur first. We dish the earth between the piles in the form of the structure that's required, and we use that to pour our slab, our ceiling slab, and then our beams, leaving holes where after we've poured that structure, that permanent lid, as it were, on top of the walls, the piling, is effectively the temporary formwork, but it becomes the permanent formwork. And then we start digging the earth out from underneath. So we're doing it in reverse, and that way you've eliminated the need of temporary formwork and you've reduced your construction costs by 30%.
ایده‌ای که ما داشتیم این بود که ما در یک پروسه پایلینگ بیایم یک سری سوراخ درست کنیم اینجا و اون سازه موقتی رو به جای اینکه یک سازه موقتی نصب کنیم توش بتون بریزیم و یک چیز ثابتی اونجا قرار داشته باشه و بعد ما اون حفره رو بکنیم و با این کار در واقع یک سازه دائمی ما اونجا داریم که دیگه ضرورت وجود این سازه موقتی رو از بین میبره و در نتیجه حدود 30% همونطور که گفتم هزینه ساختمون رو کم میکنه.
And why does that matter? It's not so much, I mean, obviously the saving 30% cost is important, but it very quickly informs us of the aesthetic that might be possible, because really we're using the earth itself as the beginning of the architectural language here, as opposed to looking to the past of other precedents of metro systems, which tend to be pretty similar. But here we're saying the earth itself is creating the architectural language. So the engineering and the soil, using the soil as formwork, is beginning to create the architectural language. which then informs the landscaping strategy. So instead of our entrances to the metro station being the classical glass and stainless steel canopies, the references to Hector Guimard or developments of the Hector Guimard Paris metro systems. Here, what we're saying, our entrances to the metro stations could be part of that landscaping park that connects all the other parks, and it's really fissures opening up of the landscape, going into the underworld. So it's a journey into the underworld and then back up again.
چرا این اهمیت داره؟ به این دلیل که ما داریم از خود زمین و از خاک استفاده میکنیم به عنوان مساله ساختمانی، از خاک به عنوان قالب بتون داریم استفاده میکنیم و این به ما کمک میکنه که یک زبون جدید معماری تعریف کنیم، برخلاف ایستگاه مترو حالت عادی که با شیشه و فلز ساخته میشن. اینجا این تو طراحی لندسکیپ هم به ما داره کمک میکنه و یک زبان جدید معماری شامل این خاک و لندسکیپ و مساله طبیعی که اونجا هستش برای شکل گیری این استفاده میشه.
So you can see there, it's the earth that has formed our walls and ceiling, and then that exit from the underworld to the park beyond.
و همونطور که می‌بینید همون زمین و خاک بودن که دیوارها و سقف رو تو این پروژه تشکیل می‌دادن.
And the key there is it's the integration of engineering, as we were discussing at the beginning, with the architecture. So the architecture is taking its being informed by the engineering, but not completely dictated by it. So the two derive something that neither would have been able to achieve alone.
و این ربط داره به اون بحثی که قبلا داشتیم در مورد مهندسی و معماری، این که معماری صرفاً دنبال روی مهندسی نیست که داره ازش استفاده میکنه و این دوتا خیلی به هم نزدیک شدن تو این پروژه.
I'm introducing this project. It's a very small project, but it's key to where we then began to look into stone. This is a small house, again, in the Kensington Bayswater area, which the family asked us to renovate. It had been played with over 50 years by different people. We wanted to reintroduce its original stone staircase. And there is a particular type of staircase that disappeared in this country in the post-war period, post-First World War period, really. And it's what you call a reciprocally, part cantilevered, part reciprocally loaded staircase. So since the medieval period all the way into the early 20th century, people have been making stone staircases, but if you look carefully, one tread is resting on the other, and the treads are lightly keyed into the wall. This doesn't require any steel or concrete or any reinforcing. It's just the ability of the load to be carried from one step to the other and then keyed lightly into the wall. So it's not cantilevering out the wall, but it's just lightly keyed and so partly cantilevering, but mostly really resting on the staircases.
و حالا این پروژه توضیح میده که این علاقه ما به سنگ از کجا شروع شده. یک پروژه بازسازیه که ما تو این پروژه اومدیم از این ظرفیت سنگ و این نوع پله سنگی که سالهاست کسی ازش دیگه استفاده نمی‌کنه و یک چیز المان خیلی تاریخی محسوب میشه استفاده کنیم. دوباره پله‌ای که سیستم سازیش ترکیبی از کنسول و باربر بودن هست، به این شکل که نیرو تو این پله ها از هر پله به پله دیگری منتقل میشه، هیچ سازه دیگری اینو نگه نداشته و در نهایت این پله به دیوار یک جوره تو دیوار و اسلب سنگی یک جوره قفل شده و صرفاً تحت بار خودش و وزن خودش وایستاده.
Now, this knowledge had been forgotten until the late 80s when a structural engineering group, Price and Myers, were trying to understand how these staircases worked. I mean, most structural engineers, pretty much all structural engineers had forgotten how to do it. We'd lost the art of stonemasonry in this country. So it was a mystery. So for us, it was a pleasure to rediscover and reintroduce with less material. So it was just the stone doing its own work.
و این دانشش تقریبا از بین رفته بود تو انگلیس و کسی از سال دهه 80 هم کسی استفاده نکرده بود و ما سعی کردیم این رو دوباره پیدا کنیم و ببینیم که چجوری این پله ها رو میساختن.
We used software that obviously could model the entire staircase beforehand, but we also used that software to be able to say, if you're cutting one piece of stone, making spiral staircases out of stone can be wasteful. You lose up to 50% of the material. But we realized if you take one rectangular block of stone and you cut it, and not as a straight line and lose 50% because there's no use, but you cut it on a tilting straight line, as it were.
Mm-hmm.
And in this case, with drills, you can actually take the other stone and use it on another part of the staircase. So you're not wasting any stone.
Mm-hmm. و بعد ما به روش برش این سنگا فکر کردیم که چجوری این سنگا حروم نشن و این پروفایل اینا رو وقتی بهش فکر کنین از هر قطعه سنگ وقتی به صورت کج اینا رو میبرین 2 قطعه پله میتونه در بیاد که ما ازش استفاده کردیم.
And while we visited the stonemasons, we could see these large blocks arriving, and we're thinking, well, you know, this is in preparation for other to be cut down into other materials, including the staircase. But clearly, that's of such a scale you could easily use that as a column or a beam.
و این سنگو که ما سفارش دادیم دیدیم که در این قطعات و در این حجم بزرگ میاد و به این فکر کردیم که اندازه اینا کاملا مستعد اینه که حتی بتونن ستون باشن یا بتونن تیر باشن این سنگ‌ها و ازشون به عنوان المان‌های سازی استفاده کنیم.
Which leads us on to Clerkenwell Close. So if you look at the close, the street here, some of you will immediately recognize that these are not original buildings. They pretend to be original buildings, as in 18th and 19th century brick structures.
و این ما رو برد به این پروژه که می‌بینید، پروژه سنگی. در کنار تو این خیابون یک سری ساختمان آجری می‌بینین که اینا میخوان ادای ساختمان. شما شاید فکر کنین این ساختمان قرن 18 و 19 هن، ولی در حقیقت دارن ادای اون ساختمان رو در میارن و به شکل اون ساخته شده.
This is because somebody in the 1970s wrote a conservation area guideline suggesting that any new buildings in this area must be predominantly brick. And if you do not argue, if you do not debate this idea, and just out of expediency, you want your building so you can rent it and make some money, you don't argue. You just put up a brick facade on a steel or concrete frame.
و این دلیل این قضیه اینه که یک کسی در 1970 اومده و یک قانونی در قانون شهرداری اینجا نوشته که هر ساختمان اینجا ساخته میشه باید عمده مسائل استفاده شده در این ساختمان آجر باشه و هر کسی انگار که مجبور این پوسته آجر رو حتی اگه سازه متفاوتی داره ساختمان روی نما بکشه.
And this creates a self-perpetuating, a self-fulfilling prophecy of fake heritage.
و این یه جورایی یک فرهنگ فیک بودن، یک جور درست کردن یک نمای فیک که میدونیم واقعا تاریخی نیست ولی ادای نمای تاریخی رو در میاره رو ترویج میده.
Which returns us to Barrett's Grove, because you might ask, well, who cares? Yeah. Well, if we say there's an ethical framework for caring, is it more expensive? Does it cost the client more than it needs to because you are using twice the amount of superstructure to hang this brick? Are you using concrete and steel where you could actually use other materials to lower the embodied carbon? If you begin to structure it with that, instead of simply saying, well, my conservation officer says I must use brick and I will just do it, you might begin to seek for other solutions, which is our target.
و شاید اگه بپرسیم باز چه اهمیتی داره که این نما باید باربر باشه یا ساختمون باید صادق باشه، باز برمیگردیم با اون بحثی که در ابتدا داشتیم که وقتی شما میتونید ساختمان رو با هزینه کمتر بسازین به جای اینکه از بتون و فولاد استفاده کنین، از سنگ استفاده کنین که در واقع کربن مصرفی کمتری هم داره و برای محیط زیست بهتره، در نتیجه این گزینه اخلاقی تریه و چرا ما این کارو نکنیم.
This is one of the earliest maps of London. You can see the Tower of London there. So that's its castle, the Norman castle. And then the rest of it is actually the original Roman wall, because you have to remember London is created by the Romans. So London proper was effectively that side, that north side of the Thames. And our site is actually this one here. That's where we're located in Clerkenwell. So just outside the city walls. And that's because the Normans, when they arrived, there was no castle there, couldn't enter London. The walls were too well defended, and they just made a deal with the people of London that they wouldn't enter London, they wouldn't sack it, they would just make a deal, yeah, and rule the country while London was allowed to rule itself.
و اینجا داستان تاریخی میگن از اینکه نورمن ها که وارد لندن میخواستن بشن به خاطر این دیوار تاریخی رومی که دور این کشیده شده و اینکه یک سمت شهر هم رودخونه تیمز هست، عملا شهر محاصره شده و امکان ورود نداشتن و میان یک قراری رو میذارن با نورمن ها، با ساکنین اونجا، که به جای اینکه بیان وارد شن و تصرف کنن اونجا رو، همون حکمرانی رو اونا به همون شکل پیش ببرن که نورمن ها در سرزمین خودشون پیش ببرن.
Our site itself is actually just, oops, let me see if I can annotate.
Let me add something. این سایت، این پروژه دقیقاً بیرون این دیوار تاریخی قرار داره که مشاهده می‌کنید، اسمش کلرکنول هست.
So our site is just located there. I don't know if you can see that green dot. Yeah. So this is an Augustinian nunnery. And then to the south, so the Augustinian nunnery, the enclave, is actually that. And this internal street is Clerkenwell Close. And that still exists today. As do these four lines as separate streets. But otherwise, all the buildings and everything else have gone.
اینجا در واقع یک صومعه سرا بوده در این محل و این خیابونی که می‌بینیم به اسم کلرکنول از اون موقع اونجا بوده و این خیابون همچنان، امروز ساختمان‌ها اونجا نیستن ولی این خیابون همچنان اونجا قرار داره.
Okay. So those first buildings were created by the Normans when they arrived in England. So this is 1066. The Normans invaded from France, and you have to remember the Normans were actually Vikings, so a couple of generations of Vikings living in France before they became formalized as French barons. And part of the deal with the king was, I will make you French barons, do not invade any more land, the land is yours, we'll call it, because you're Norsemen, we'll call it Normandy, and you're barons of Normandy. Do you want to translate?
Yeah. و اینجا این محلیه که در همین نورمن ها که اشاره کردم بهش اومدن وارد شدن بیرون دیواره شهره و گفتم اون قراردادی که با شاه داشتن در اونجا و قرار شد که اونجا همون حکمرانی رو داشته باشن مثل در واقع جایی که در کشور خودشون دارن و اسم این منطقه رو، ولی چون دیگه اونا تو منطقه خودشون در فرانسه نبودن نورماندی میذارن و یک جور وایکینگ های اون زمان بودن که فرهنگ خودشون آورده بودن به این محله بیرون از دیوار تاریخی لندن.
So as well as swearing allegiance to the French king, they had to convert because they were pagans, they were Viking pagans. They had to convert to Christianity. But one part of the reason they were so successful, Norman France, is one, they were good fighters, but they discovered that when you cut limestone from a quarry and it's still quite wet, it's actually very easy to carve, very soft to carve, and it takes about 6 months to a year to absorb carbon dioxide and become very, very hard. So they built their fortifications. Everybody else was building their fortifications from rubble walls. They built their fortifications from cut limestone, keyed it together, and they became incredibly strong forts.
و اینا حالا اومدن و فرهنگشون رو باید تطبیق میدادن، نورمن ها باید مسیحی میشدن و غیره، ولی حالا در امتداد اینا یک کشف مساله یک کشفی کردن که این مساله لایمستون یا سنگ آهک مسئله که خیلی راحت بریده میشه و خیلی ترده و یه چیزی بوده 6 ماه تا 1 سال طول میکشه تا اینکه کربن دی اکسید جذب کنه و کاملا سفت بشه و با این تکنیک اینا تونستن ساختمون‌هاشون و این قلعه هاشون رو با این مسئله سنگ آهک بسازن به جای سنگ‌های ریزتری که بقیه استفاده میکردن.
So when they first came to England, they removed the entire Anglo-Saxon aristocracy, the ruling class, and took over the country. Initially with those fortifications, famous castles, lots of them still exist. And after they subjugated the entire population, they began to build these fine cathedrals and churches and nunneries, because as newly converted Christians, they realized, okay, we've managed to become incredibly wealthy, but we're going to go to hell. How do we stop going to hell? Well, we'll build these monuments to Christianity, and the what normally happens is the bishop writes a certificate saying, thank you very much for building this fantastic cathedral and nunnery and a monastery. Here's a certificate forgiving you for your killing. You'll be sure to go to heaven. And in this particular site, the Baron actually put his wife in as the first abbess of the nunnery. So he built her and she gave him the certificate.
Wow, و توی این توضیحشون میگن توضیح مفصل تاریخی در مورد نورمن ها، میگن اینا اومدن و خلاصه اون منطقه رو تصرف کردن و تونستن این ساختمان‌های خودشون رو با این مصالح سنگ آهک بسازن و شروع کردن حالا ساختن کلیساها، به این دلیل که خب کلی توسعه پیدا کرده بودن، پولدار شده بودن و جنگ‌ها رو پیروز شده بودن، ولی به خاطر اینکه مسیحی شده بودن می‌خواستن که در واقع یک جورایی جواب خدا رو هم و از این طریق میان و صومعه سرا میسازن، کلیسا میسازن و سعی میکنن که این رو گسترش بدن و بارون این نورمان ها هم اومد و همسر خودش رو توی یکی از این ساختمون ها گذاشت و این فرهنگ ساختمون سازی با این مصالح جدید مرسوم شد در این دوره.
Now, remember also, we're outside the city walls, so the rules aren't quite as strict. So when you're inside the city, breaking the rules is you're immediately in the courts. While if you're outside the city, you could just get a little bit, get away with a little bit more.
و به خاطر داشته باشین چون این محله بیرون اون دیوار شهره، بیرون قسمت شهر رسمی محسوب میشه، یکم قوانین راحت‌ترن و راحت‌تر میتونید هر کاری که دوست دارید انجام بدید.
Anyway, for 500 years, the monasteries and the Catholic faith flourished in the country until Henry VIII decided he wanted to, divorce and get remarried, and obviously fell out with the Pope, decided he's no longer part of the Catholic faith, and all Catholic institutions must be banished, which was very good for him because he basically took all their land and all their wealth. But he couldn't do it by himself. He had to have his trusted companions. And on the top left is the Duke of Norfolk, who also converted from Catholicism to Protestantism. And he sacked the nunnery and took the land for himself as his private palace, and whatever gold and other material he could find, he gave to the king.
و خلاصه 500 سال تاریخ کاتولیک بودن دارن این انگلیسی‌ها در این دوره و بعد 500 سال هنری هشتم تصمیم میگیره که زنش رو طلاق بده و زن جدیدی اختیار کنه، همسر جدیدی اختیار کنه و سر این قضیه با پاپ دعواش میشه و داستان‌های تاریخی که میدونین میان از در واقع زیر دست کاتولیک‌ها آزاد میشن و یک جورایی خوبم میشه براشون کل اون زمینا رو که متعلق به کلیسا بوده تصرف میکنه و برای این کار تنها نبوده، کمک دوک نورفولک رو داشته که سمت چپ بالا میبینیمش، کسی که اومد و اون ساختمان صومعه سرا رو تصرف کرد به اون یکی از ساختمان‌هایی که قبلا متعلق به کاتولیکا بوده. خودش قبلا کاتولیک بوده و بعدا میاد و پروتستان میشه.
The family, Duke of Norfolk's family, used it as their private palace until his son became the Duke. And his son did not like Elizabeth I because, one, he didn't believe a woman should be head of state, and two, he wasn't quite convinced of being a Protestant, and he conspired against her. His head was removed, and the family were removed from the land, and it was subdivided and given to other loyal nobles who demolished part of the abbey and built their own palaces and houses. So slowly the abbey began to diminish.
و خلاصه این آقای دوک نورفولک با خانوادهش مشکل پیدا میکنه، پسرش تصمیم میگیره پروتستان نباشه و غیره و این خانواده از هم میپاشه و در پی اون تصرفاتش هم این که این مجموعه تاریخی، این قلعه شروع میکنه به تحلیل رفتن و تخریب.
And that's the way it stayed until Oliver Cromwell, who's the next one on the left, decided to dissolve the monarchy. And he took all the land for himself, got rid of the nobles, took all the land himself, demolished all their houses and 90% of what was left of the abbey, and built himself a new house of state. So Whitehall is where the royal family lived with their servants and their advisors. And Oliver Cromwell built himself a new house of state on Clerkenwell Close.
و بعد در اپیزود بعدی داستان ما داریم این آقای الیور کرامول رو نفر دوم که تو تصویر میبینید که این میاد و این از کسانی بوده که بعد از ملغا شدن سیستم پادشاهی در انگلیس میاد تصرف میکنه این ناحیه رو برای خودش یک خونه بزرگی در این سایت میسازه.
However, this is a nascent democracy, so Oliver Cromwell was convinced this was going to be a new order, but it wasn't going very well. The members of parliament were voting themselves in every year without actually going for any votes to the public. So he decided he was going to become dictator for life. And on his death, his son would inherit the dictatorship. But of course, on his death, his son was overthrown, the monarchy restored, the nobles came back with their legal deeds, land deeds, and Oliver Cromwell's palace and building of state was demolished.
و بعد دوباره همون بلا سر این آقای الیور کرامول هم میاد که میاد و یک جورایی از اون سیستم سیاسی نوظهوری که تأسیس کرده بوده به مشکل میخوره و تصمیم میگیره که یک دوباره شاه باشه و اینا و بعداً با سیستم سیاسی هم که اون مبدعش بوده در واقع دوباره ازمهلال پیدا میکنه و سیستم مونارکی برمیگرده و خلاصه اون خونه‌ای که ساخته بوده رو تخریب میکنن باز.
The nobles built houses for rent, and with London's economic boom, the population increased, factories increased, and the next person on the left is William Morris. So this is during the Victorian period. The area became notorious as slums and for industry. And because it had always been outside the city walls and the rules were a bit more relaxed, this particular area was well known for pamphleteering, printing. You could print whatever you like. And Fleet Street, the River Fleet was next to our side. And Fleet Street obviously is the home for the English newspapers. Oliver Cromwell built, William Morris, who most of us will know as a designer, slash architect, built what he called, this is during the 19th century, what he called the 20th century press, a press looking to the future. And he met Karl Marx. Karl Marx wrote for that newspaper. So remember, this is an area already of radicalism, so it attracted radical thinkers. Lenin wrote for the newspaper and printed his Russian language newspaper, which he then smuggled back into Russia. And today, this site is still used as the start of the annual May Day March. Our building is just behind the printing press, so we're right next door to it. So there's a long history of change, demolition, rebuilding, radical thinking.
Okay, let me briefly say that. ویلیام مورس که معمار معروف قرن 19 که میشناسیم در انگلیس، این شخص دیگه‌ایه که میاد و در این دوره که دوره پرتنشی بود در نظر اجتماعی در انگلیس، فاصله طبقاتی بسیار زیاد شده بوده و نشریات هم زیاد شده بودن، میاد و یک ساختمون نشریه‌ای رو تأسیس میکنه و ساختمونی رو براش بنا میکنه و تو این نشریه آدمای معروف مهمی در اون زمان از کارل مارکس گرفته تا لنین به زبان روسی میان مطلب مینویسن و خلاصه این ساختمون مطبوعات که اینجا میبینین تو تصویر دقیقاً پشت این ساختمون پروژه قرار داره که خیلی تاریخ مفصلی رو در پی خودش داشته.
So our first design on the site, because we weren't while we were in the nunnery, we were actually, our site is originally on the site, on the area of the servants' quarters, the timber buildings, the stables, etc. That would have been what they call half timber structures, an excess skeleton of timber filled in areas with plaster. Mm-hmm. And we wanted to look to see whether we could allude to this original type of structure, but use a parametric software, a self-learning software, where we would say, traditionally, office buildings, large-scale office buildings might be built of steel frame. They have a unitized glazing system. Even if the unitized glazing system tries to hide the metal, ultimately, when the lights are on, the metal frames end to end become quite large. Can we give that information to the software and see whether we can reduce the amount of metal? What would be actually the most efficient way of constructing this? The result was an exoskeleton of metal that reduced the metal by about 30%. And you can see there how the diagonals begin to modulate in plan and section that metal. So thin, slightly thicker at the bottom and then thinner at the top.
خب تو این سایت که اون ساختمان صومعه سرای قدیمی وجود داره که بهش اشاره کردم، ساختمانایی بودن که بهشون اصطلاحاً هفت تیمبر میگفتن، ساختمانایی که سازه داخلیشون با چوب ساخته شده بوده و پشتش از گچ استفاده میکردن. و حالا ما تو این پروژه اومدیم و اون رو باز تفسیر کردیم و با استفاده از در مرحله اول، امتحان اول، اومدیم سعی کردیم با فولاد و شیشه این رو بسازیم و سعی کردیم این فولاد رو اپتیمایز کنیم و ببینیم که چجوری میتونیم حد اکثر کیفیت بستری رو از این مدول ها بگیریم که بعداً در پلان هم برای ما نقش داشتن و حد اکثر زخامت، حداقل زخامت رو اینا داشته باشن و کاملا ثبات باشن.
So this is us alluding to the history of the physical history of the site. While also trying to reduce the amount of material in the structure. The planning departments in this country are subdivided between a case officer, a planning case officer, and all the other departments: drainage, refuse collection, green parks, and conservation and preservation of historic fabric. But ultimately, the case officer makes the decision. But there was an argument between our case officer and the conservation officer. And the conservation officer wanted to use stone. He was new to the area, and somehow he believed stone, not brick, should be the material. And we have no prejudices against different materials. And we thought, instead of letting them argue, why don't we just investigate stone? And this is obviously how pretty much every stone building in the world tends to be, modern building, tends to be constructed in a steel or concrete frame with a veneer of stone.
و بعداً بحثی در گرفت بین کسی که مسئول در واقع حفاظت از ابنیه تاریخی در این محل بود و مسئول فنی این ساختمون و اون شخص حفاظت تاریخی. نظرش بر این بود که ما از سنگ استفاده کنیم برای مسائل ساختمون و خب ما به این فکر افتادیم که حالا به جای فولاد چجوری میتونیم در مورد مسائل سنگ تحقیق کنیم و بیایم از اون استفاده کنیم به عنوان یک مسائل مدرن.
And if you remember from that stone staircase at Caroline Place and seeing these blocks, we asked the same stonemason, is it possible to construct in stone blocks? And he's a French stonemason in France. They still train stonemasons to work with structure. In this country, we don't anymore. We just ask them, we train them to decorate only. And he said, of course it's possible. For millennia, mankind has been building in stone, and the period of steel and concrete in the timeline of construction is very, very small. There's no reason why we can't return to stone and timber as a structural material. Use the same software to size columns and beams, and I will tell you how much it costs to extract the stone, transport it, and put it on site. And it turned out to be 25% cheaper than a steel or concrete frame clad in stone.
و خب ما اومدیم از سنگ استفاده کردیم با پشتوانه‌ای که قبلا اون پله سنگی بارور رو هم ساخته بودیم و مسئله‌ای که تو انگلیس وجود داره اینه که برخلاف فرانسه که تمام این استون میسن‌های اشخاصی که در واقع بنای سنگ به قول معروف هستن یاد میگیرن چجوری سازه بارور سنگی طراحی کنن و بسازن، تو انگلیس فقط این بناها یاد میگیرن چجوری یک نمای فیک سنگی درست کنن، نه و قسمت باربری اینا رو یاد نمیگیرن و خب یک دانش یکم تو که گفتم از بین رفته. ولی ما این اعتماد رو داشتیم، میدونستیم که انسان قرنها از سنگ استفاده کرده برای ساختمون و سازه و نسبت دوره‌ای که از سنگ استفاده شده خیلی بزرگتره نسبت به دوره‌ای که از فلز و بتون استفاده شده و گفتیم که بیایم از همون نرم افزاری که برای تعیین ابعاد سازه در حالت عادی استفاده میشه، ستون و تیر، استفاده کنیم برای اندازه گرفتن ابعاد مورد نیاز برای سنگ ها و این پروسه رو شروع کردیم.
He then took us to quarries to look at how the stone is extracted. And part of the reason it's so much cheaper today instead is there's not so much hand labor. It's all machined and the machines are quite efficient. So here you can see a 30-meter long cut made with a rotating cable with industrial diamonds on it that cuts these 30-meter long lines. And then the next machine is a drill that then splits that stone. Occasionally a stone will still fall out that you still have to hand tool, but on the whole, it's industrialized. And this is actually one of the smaller quarries. So actually a larger industrial quarry will use chainsaws that are about 9 meters long. And instead of getting different finishes from the cutting, those quarries will just give you clean cuts on all sides. This type of quarry, which uses the splitting the sedimentary layer, drilling and cutting, will give you 3 types of finishes. And to us, it began to inform how the architecture might then become manifest. So obviously, it's also sedimentary stone, so you'll get occasionally fossils and quartz pockets in it.
و خب مطلبی که وجود داره در رابطه با استفاده از سنگ، دلیل اینکه امروز ارزان‌تر در میاد از گذشته هم اینه که صنعتی شده و کاملا به صورت صنعتی در معادن سنگ اینا بریده میشن با استفاده از یک کابلی که الماس برش صنعتی داره و بعد در جهت دیگه استفاده از اون اره‌های بلند 9 متری برای بریدن این سنگا و کاملا صنعتی شده این پروسه. و حالا تو این پروسه صنعتی بعضی از معادن میان و سعی میکنن سطوح صاف ببرن کاملا و صیقلی کنن سنگ رو، ولی این معدن مشخصی که ما باش کار میکردیم 3 تا فینیش مختلف به ما داشت پیشنهاد میداد و این فینیش زبر سنگ شروع کرد ما رو الهام بخش ما بشه که شاید بتونیم از یک فینیش متفاوت استفاده کنیم تو پروژه‌مون. و همونطور که تو تصویر قبلی دیدین حتی تو این برش‌ها فسیل مشخص شده بود یا سنگ کوارتز در درون این سنگ در اومده بود.
So the detail is because the UK is not a seismic area, we don't need any bracing. We don't need any stitching of the stone. It can actually just be laid on one on top of the other and just held by gravity. If you're in a seismic location, you have to do some more stitching. And what we're doing in those sort of locations is pre-tensioning the stone. So drilling a cable through it, tensioning it, and then tying the perimeter of any exoskeleton together. Here, it's just gravity holding one stone on top of the other, and then a thermal isolation detail to stop thermal bridging.
همونطور که شاید بدونید انگلستان روی گسل زلزله قرار نداره، در نتیجه ما ساختمون مجبور نیستش که سازه هامون بادبند داشته باشه یا در برابر نیروی جانبی مقاومت کنه یا به صورت اوریب فیکس بشن. در نتیجه شما ساختمون رو صرفاً در برابر بیشتر نیروی ثقلی این رو میتونید سنگ رو سنگ بچینید و بیاین بالا و این خب کار ما رو راحت‌تر میکرد از این جهت. و همینطور برای عایق هم برای اینکه باید ترمال بریجینگ دیتیلش اتفاق بیفته باید ما پشت این سنگ ها رو یک جوری میبستیم، یک لایه استفاده میکردیم که همیشه یک عایقی بین بیرون و درون باشه.
This is now was conceived in 2011 and then built over 20 16, 17. And at that time, we put in concrete floor slabs with on temporary props ready to take this exoskeleton. And there you can see the exoskeleton in plan. And then this 300 millimeter gap between the exoskeleton and a nice, clean, sealed skin. Now, what that means is you're spending less energy cutting holes or perfect lines in the stone to insert your windows and weather them. Here, the stone can be left as rough as possible, connected to the floor plate with that thermal isolation detail, and then you get a very nice, easy weathering skin behind that.
و این سنگ‌ها رو ما سال 2011 دریافت کردیم و تقریبا 2016 17 شروع کردیم به چیدنشون. همونطور که تو تصویر می‌بینید یک سری اسلب‌های بتونی ما داریم اونجا که با سازه موقتی نگه داشته شدن و یک اگزواسکلتون، یک اسکلت سنگی که از بیرون اومده و به اینا وصل میشه و یک فاصله 30 سانتی متری هست بین لبه این اسلب‌ها و اسکلت سنگی بیرون که اونجا قرار داره و باعث میشه که خب ما چون این فاصله بین نمامون هست یک استقلالی پنجره هامون داشته باشن و در نتیجه برش سنگا نیاز نیست که تمیز و صاف بریده بشن تمام قطعات سنگی.
And then the exterior really is dictated by the stones as they come out the quarry. So a master block for the lower floor will be cut in forso. So we know we have sedimentary layer, 2 cut lines, and then drill lines at the edge. As you rise up the block, the stones get smaller, and then counterintuitively at the very top they get heavier to deal with wind loading. So to avoid wastage and more energy being burnt in cutting, getting every single stone perfect in its appearance, we just allowed the extraction process, the skill of the quarry master, therefore, to begin to speak about the of itself in the architecture. So the architecture is the expression of quarry master, the stonemason, and the engineer with his software.
یک مسئله که یکی دو تا اسلاید قبل اشاره کردم من فراموش کردم بگم این که این سنگ‌ها به صورت پیش تنیده ساخته شدن، یعنی به هم وصل شدن، یعنی یک حفره ایجاد شده و با یک سری کابلایی به هم فیکس شدن از این طریق به هم متصلن و بعد این قطعات سنگ‌ها اومدن و این ایمپرفکشنی که دارن به این دلیله که خب از هر قطعه بزرگ سنگ وقتی تقسیم میکنن دوور صاف داره و دوور در واقع دو وجه که راف هستش و زبر هست و اینا رو اومدن در ترکیب با هم استفاده کردن که حروم نشه مصالح و از تمام این قطعات استفاده بشه و همینطور قطعاتی که بزرگ هستن سایزشون بزرگتره، پروفایلشون در ارتفاع کمتر پایینتر استفاده شده و هر چی سازه به سمت بالا میره و نیاز به در واقع سایز قطعات سازه کوچیک‌تری داره قطعات کوچیک بالا استفاده شده و این پروسه از اون مسئول معدن سنگ شروع میشه که بریدن این قطعات و استفاده ازشون تا اون بنای سنگ و بعد تا نهایت تا اون نرم افزاری که داره اینا رو محاسبه میکنه سازه و معماری که این پروسه طی میشه تا اینا ساخته بشه.
So really from a distance the architecture is really speaking about how it's made. It's very straightforward. It's just the stone and the engineering. As you get closer you have tactile details at ground level that you're quite close to and you actually see touch and see at close quarters. And these details are the narrative details. They're the details of the door handles and other areas that seem to be mysterious, but they speak then of that history that's beneath our feet, that's vanished, that Norman history, that post-Norman history. That's gone. So the seashells, the various details, medieval details, as well as the fallen Ionic part carved column, are details of a period when the abbey was dissolved. So it dates it, and it also speaks of the removal of St. Mary's Chapel, replacing it with St. James's Chapel. So there's a narrative history to the past in the tactile details at ground level.
و این ساختمان شما وقتی از دور میبینید خب یک سازه سنگی و یک نتیجه یک مهندسی رو شاید ببینید، ولی وقتی بهش نزدیک میشین یک سری جزئیاتی میبینید، دیتیلایی میبینید که بازی با مصالح زبری و صافی اون فسیلا و دیتیل‌ها و قطعات مختلف هستن که اینا همه دارن یک نراتیو یا یک روایتی رو میگن در مورد این ساختمون و موقعیت تاریخی که داشته تو این سایتی که پر از تاریخ هست، تاریخ نورمان ها هست و استفادهشون از این مصالح زبر و مشخص، این سنگ آهک و همه این زبان معماری میخواد که اون رو روایت کنه و دوباره بازسازی کنه.
The advantage of having an exoskeleton is there's no internal columns, so the floor slab is entirely clear. So what we call here loose fit. So it's a piece of clothing that fits loosely and therefore can fit multiple people. So in the future, you could subdivide it into more flats. You could subdivide it into a hotel. You could clear it all out as office space. So in terms of its long-term sustainability, it has advantages by being entirely free of structure in the interior.
و خب مزیتی که استفاده از این سیستم اگزواسکلتون داشت، این سنگ‌های باربری که در نما می‌بینید، این بود که ساختمان نیازی به ستون در داخل نداشت و یک فضای بزرگی یک دسته که کاملا فلکسیبل، هر طور که بخوام میتونن بچینن، مثل لباس لوس فیت، مثل لباس میمونه که یک سایزی که به تن همه میخوره. این ساختمان میتونه در طول زمان به انواع مختلفی داخلش استفاده بشه.
And then the interior can be well, we built it all in timber. So instead of aluminium partitioning, aluminium stud-work with 2 layers of plasterboard, plastering, skim coating it, painting it with the architraves and skirting boards, we just use single sheets of timber to go from floor to ceiling and timber stud-work for everything. So if you then add up all that timber as carbon sequestrating material, it begins to balance out against the cement we used.
و ما در داخل هم برای این پارتیشنایی که می‌بینین از چوب و تیمبر، مصالح چوب مهندسی شده استفاده کردیم، به جای اینکه بیایم از آلومینیوم و گچکاری استفاده کنیم که خب خیلی کربن کمتری براش مصرف میشه و خیلی دیتیل‌های تمیزتری داره.
The roof is what's called a blue roof. So in this country, any rainwater cannot be allowed to go into the sewage system because it would overflow the sewage system in the rainy period. So you have to keep the rainwater on your own site. And normally this is done by creating a basement with a tank in it and then pumping the water to different parts of the building, maybe the roof again for a green roof. But if you allow all the rainwater to sit on the roof itself, then you can put a green roof with its roots above it. And if you use trees instead of just grasses, that's enough plants to then suck up to drink all that rainwater.
Interesting. And this is called blue roof.
Blue and green roof.
Okay. توی لندن یعنی که ما به خاطر بارش شدید سیستم فاضلاب تحمل اینو نداره که همه آبی که در واقع حاصل میشه از بارون رو جمع کنه و ساختمونا اغلب آب محوطه خودشون رو باید در خودشون ذخیره کنن و نگه دارن. اغلب این ساختمونا یک تانکی دارن در زیر زمینشون که آب اونجا جمع میشه و بعداً پمپ میشه به جاهای مختلف ساختمان برای استفاده. ولی توی این پروژه مثل بعضی پروژه دیگه ما اومدیم از سیستم که بهش میگن سقف آبی علاوه بر سقف سبز، سقف آبی و سبز اسمش میذارن که به جای اینکه ما یک روف گاردن با گیاهای کوچیک داشته باشیم، درختای بزرگ داریم و این درخت‌ها بزرگ باعث میشن به خاطر ریشه های بزرگی که دارن تمام اون آب رو مصرف کنن و بکشن به خودشون و در نتیجه صرف ساختن این سقف سبز میشه.
Since then, we were asked by Canary Wharf and Derwent, who are London office developers, is it possible to build towers, larger structures in stone? So we investigated with a structural engineer and stonemasons, and they gave us their brief, which is a 30-story tower, and the answer is yes. You can make it out of stone. You can even make the floors out of stone, and that's done with a post-tensioned or pre-tensioned floor slab. what we found out with our sustainability engineer is that on the far right, is the embodied carbon of a concrete frame building with stone cladding. The next one from the far right is steel frame. Now, steel has got a higher embodied carbon level than concrete. On the far left is if everything was made out of stone, the floor slabs as well as the exoskeleton and the core itself. But in the middle, scenario 2 is if the floor slabs are made of cross-laminated timber. So the material we used at Barrett's Grove. Because it's carbon sequestrating, that means your building is effectively carbon negative. So as a thought experiment, really what that's saying is if you balance the amount of timber you use with your stone, building something actually takes carbon out of the atmosphere. So it changes the narrative from us worrying that just building anything is bad for carbon dioxide levels in the atmosphere. Actually, if you carefully balance the amount of timber with your stone, building actually helps reduce the amount of carbon dioxide in the atmosphere.
و ما توی بعد از اینکه این پروژه رو ساختیم از یک سری دیولپری که پروژه اداری رو اینو دیولپ میکنن از هم پرسیدن شما میتونید این پروژه رو در مقیاس بزرگتر پروژه آفیس اداری طراحی کنید با استفاده از همین سنگ. ما یک مطالعه کردیم و با تحقیقاتی که با این معدن سنگی که باهاش کار کردیم انجام دادیم فهمیدیم که بله میشه ساختمان‌های بلند ساخت با استفاده از همین سنگ، حتی میشه اسلب سنگ ساخت و اینا رو با استفاده از متد پیش تنیده اینا رو مقاوم کرد و کلا اسکلت سنگ خالص ساخت. و حالا تو این دیاگرام تو این چارت ما مقایسه کردیم که بخش‌های مختلف ساختمان از جمله کور، قاب‌ها و دیوارها و اسلب‌ها رو اگه با مصالح مختلف سنگ، بتون و چوب مهندسی شده بسازیم، اینا چه تأثیری دارن بر این در مورد کربن مصرفیشون و اینکه چقدر زیست محیطی هستن، برای محیط زیست مناسب هستن. و به این فرمول رسیدیم که استفاده از سنگ همزمان با CLT یا مصالح چوب مهندسی شده یک ترکیب ایدئالیه برای اینکه ما مصالحمون ذخیره کربن کمتری، رد پای کربن کمتری داشته باشیم.
This is what we use in Europe as a standard for calculating the embodied carbon of any building during its lifespan. So you can see there in sections A, it's the embodied carbon in the materials and the construction period. If you make your building carbon negative, you cannot calculate that as carbon negative unless section C identifies those materials that at the end of the lifespan of that building, those materials are reused. Because otherwise, you could be throwing those materials into landfill or burning them and releasing that stored carbon dioxide.
و این چارتی که نشون میده توی اینجا چجوری ما میتونیم یک ساختمون رو کربن زیرو اعلام کنیم، ساختمونی که در واقع در پروسه مصرفیش از کربن کمی یا حداقل کربن استفاده شده و ما باید تمام این مراحل رو در نظر بگیریم، از وقتی که مصالح خام استخراج میشه و آورده میشه تا در نهایت جایی که نخاله ها و چیزی که از پروژه باقی میمونه قراره که بره و دفن بشه و هیچ ساختمانی نمیتونه کربن در واقع در کربن صفر در نظر گرفته بشه مگر اینکه در تمام این مراحل رو براش راه حل در نظر داشته باشه.
So this is another one that's currently on site where we're trying to make it out of stone and cross-laminated timber. It's twice the height of Clerkenwell and uses basalt stone instead of limestone because you can use half the amount of stone compared to limestone for fire and structural reasons.
و این پروژه طراحی این پروژه است که تقریبا دو برابر پروژه قبلی که دیدین ارتفاعش هست و از سنگ باسل استفاده شده به همراه چوب مهندسی شده، ترکیب سازه چوب و سنگ و استفاده از این سنگ هم به خاطر مزیتش در مسئله آتش سوزی هست که وجود داره.
Here are some more recent studies in stone, because what we've discovered is actually, if you're careful, constructing a stone is not just cheaper, but obviously the embodied carbon is a lot lower. This is simply finding your quarry stone and stacking it in a traditional way. You can see there are floor slabs which are pre and post tensioned, using them as floor slabs or sometimes lintels.
و ما اومدیم این سری تحقیقاتی رو با این سنگ‌های مستخرج شده از معدن انجام دادیم در ظرفیت مختلف در مورد بحث سازه‌ایشون و اینکه اینا رو چجوری میتونیم هم ترکیب کنیم، از استفاده کنیم از سیستم‌های پیش تنیده یا پس کشیده و بیایم با نل درگاه اینا رو ترکیب کنیم که شما این آزمایش‌ها رو تصاویرش انجام بدید.
Here is some waste stone. So this is stone that's normally cut to 10 millimeters for tiling, floor tiling or some other type of tiling. And some of it, you know, depending on the quarry and the stone that's being used, sometimes you can get up to 80% wastage where the tiles break. So what do you do with that? Well, here's a method that we've been researching with an Italian stonemason, where we bond it. And here we're using it as a double skin either side of insulation, and the material becomes structure as well as external internal finish as well as insulating material. And there's a demonstration of 30 millimeters, so 3 layers of that 10 millimeter stone bonded to become structure, a structural shell.
و این یک تحقیق دیگه که انجام دادیم با یک سنگ خیلی نازک 10 میلیمتری، ضخامت 10 میلیمتری که برای معمولا پوشاندن سطح‌ها ازش استفاده میشه و این خیلی ویست زیادی داره، خیلی تقریبا 80% این شکسته میشه و از بین میره، استفاده نمیشه ازش. ما تصمیم گرفتیم که بیایم از این استفاده کنیم، ببینیم که چطوری میتونیم از این مصالح که معمولا هم از بین میره و استفاده نمیشه استفاده کنیم و اومدیم اینها رو به هم چسبوندیم و در 3 لایه مختلف اینا با هم 30 میلیمتر شدن و تونستیم که این شل ها اون پوسته هایی که دیدین رو بسازن که باربر هستن و از هم تحمل میکنن.
I have to wait for me to there we go, I found it. A 5-bedroom house over here, if you made it entirely out of timber, would take about 20 roughly 22 cubic meters of structural timber, and you need a forest of about 2 hectares to provide you that structural timber. Obviously there's plenty of other timber left for other timber products. Now you could make the same house using the same amount of material but in stone, and obviously the quantity of stone, the area of stone would be a lot less. And this is not to say there's a binary argument between timber and stone, but just that if you're careful when you combine those materials of stone and timber, you can actually reduce the amount of material, you can reduce your embodied carbon, you can make your embodied carbon negative as well.
اینجا مقایسه کردن مصالحی که برای مثال یک خونه 5 اتاق مصرف میشه برای ساختنش بین چوب و سنگ. در بالا میبینیم ما برای اینکه چوب مورد نیاز برای ساختن اون خونه رو داشته باشیم چیز نزدیک 2 هکتار جنگل رو باید استفاده کنیم، در صورتی که برای سنگ حجم خیلی کمتر، یه چیز حدود 2 متر در 2 متر در 6 متر کل حجم سنگیه که شما مصرف می‌کنید. این البته یک آرگومنتی بر ضد چوب نیست، بلکه بحث اینه که استفاده هوشمندانه از ترکیب سنگ و چوب میتونه خیلی راهکار خوبی باشه برای ساختن.
This is a competition we recently won in Bristol, where we're trying to now build in basalt at around about 30 stories.
30 story.
Yeah.
این پروژه مسابقه که ما بردیم یک پروژه 30 طبقه هستش در شهر بریستول که با همین سنگ باسل قراره که بسازیمش.
Might be basalt, might actually be because we're talking to stonemasons at the moment, and some of them still want to use limestone, but post-tension or pre-tension all the beams and columns and structure, in which case they want to use limestone. You don't need to use basalt.
Correct me if I get it wrong, but the basalt had the benefit of being more fire resistant, right?
Yeah, so we are typically using oops, hang on a second. I'll try and draw on top of this. No, try again. No, okay. We're still using a technology of column, beam, yeah. And if you do that, then what we found after testing it, fire testing it, so you take your stone and you take it to the laboratory and you put it under load and you put it under a fire, that the limestone needs to be about twice the size of a piece of basalt. So that's twice the amount of material, which basically means you're paying for twice the amount of material, twice the amount of transportation and crane lifts and all the rest of it. So the basalt can be much smaller, it performs better in a fire. That's if you're doing it as column, beam, column, beam. If you drill 2 holes in it and pass a cable through and pre-tension it, then you can use a weaker stone, because you're not relying on the stone having all its integrities, flexural as well as load, and then performing in a fire with differential expansion along the length or one side to the other. You're actually tensioning smaller bits of stone, which means they can all perform and fail, but they're actually under tension anyway. So if something goes, if there's a crack in one, the whole thing doesn't break, yeah. Which basically means you can use cheaper, lower grade stone. So our stonemason is thinking that he would prefer to do that than single pieces of basalt across 30 stories. Have them effectively built like in his yard, like a factory, where everything, all the beams and columns are just made, put on the back of a truck and lifted into place, connected, and it goes up as a stone frame, just like a steel frame would.
Okay, thanks. Let me please translate. دارن اینجا مقایسه میکنن این مصالح سنگ باسل رو با سنگ آهک لایمستون که قبلا دیدیم تو اسلاید قبلی و بررسی میکنن کدوم دارن تو این پروسه هستن که بررسی کنن کدوم برای این پروژه بهتره و اصولا میگن در مورد آتش سوزی این سنگ خیلی مقاوم تریه و سایزش تقریبا میتونه نصف سنگ آهک باشه در موارد آتش سوزی ولی اگر که این در صورتی که شما صرفاً رو هم بچینید تیر و ستون رو، ولی اگر شما پیش تنیدگی داشته باشین تو سیستم سازیتون که مثل سنگ آهک قبلا توضیح دادن و اینا مقاومتشون رو از طریق پیش تنیدگی هم بگیرن و تقویت بشن، دیگه آتش مسئله نیست و میتونید از سنگ ارزان‌تر هم استفاده کنید.
Okay, that's our end.
Perfect. Okay, wonderful. Thank you very much.
You're welcome.
Super inspiring, and
thank you for the translation. Well done.
Of course, thanks. I hope I got it right. It became difficult when it came to history.
Just have to trust you. No idea what you said.
Yeah, so I'm going to open it to the Q&A.
Yeah.
I'm going to use my privilege to ask the first question. I really enjoyed the presentation in many different ways, but in the beginning I mentioned that you're representing an archaic image, you know, like when you talk about the benefit of using stone or brick in the building, you speak about the cost benefits and the environment benefits, but also it's about the narrative, about the culture and image that you show, that you spoke about when you were zooming in on the details of the building that I assume you're sitting in right now, and then how basically it's a language that you also care about. It's not just about the cost. And then, so to me, what I see is not fully archaic or prehistoric too. It's a mix. It's a very interesting mix of low-tech facade versus very high-tech interior. We see structural facade in the building versus free plan in the interior, which is really astonishing. Like when I think about Corbusier, he said, okay, we have modern architecture, we can separate wall from the columns. So we have both free facade and free plan. But now you're kind of hybridizing this modernist idea with the prehistoric idea. You don't have a free facade, but you have a free plan, which is interesting, this dialectic between these two, to me. And of course, the dialectic between the replica or the false history that you make and the pristine elements. Or for example, the windows that you make, that's like the facade is fully classical looking, but the front windows, they don't have any frame. They're super pristine and clean and abstract. So I see this dialectical relationship that we have in the theme of our lecture series all over in your project, and this makes these projects super fascinating to me. But I would like to hear a little more about your relation with the history. I see that you get big influences from the historical events and context baggage, and what you talk about the false history, false memory, and representing history somehow, but not fully as it was before. So what's your take on that? How do you explain this?
Well, where do we start on that one? I mean, we've got a, I mean, I'm not sure what it's like in Tehran, but here in the UK and especially London, for a long time, I guess in the post Second World War period, all over Europe, we had a new generation of politicians, architects come in who said, look, we've had two wars, First World War, Second World War, in the traditions of our fathers, as it were. We need new thinking. And with that, they promoted steel, concrete. It's emblematic of the modern period, modernism, and dare I say, throughout any lessons of the past, any useful lessons that we're learning today, relearning today, i.e. it's less material, it could be cheaper, less embodied carbon. Now, these weren't the priorities in the post Second World War period. It was about establishing and manifesting a new world. And all the way until, I guess, late 70s, it was quite common, therefore, to rid ourselves, demolish as much as possible of the past and replace it with the new world, as it were. And then by the mid-70s, a new generation of people was suggesting that this loss of heritage, this cultural loss, was dangerous to our future, to the UK or Europe's future, and that our history will have vanished, and we should retain it. It has beauty, but also it's our heritage. Again, there's a danger it gets conflated with politics, but effectively what happened was a heritage movement began, and that heritage movement has just got stronger and stronger. And now it's very difficult to suggest anything that has absolutely no relationship with the heritage. Those people who are central government, who begin to write the guidelines for heritage, are as flexible as you can possibly be. They actually say, we're not interested in rebuilding the old. Yeah. In fact, we don't like the idea that you should fake heritage. We would prefer, if you are building in a heritage area, that you are emblematic of today, because in 50 years' time, 100 years' time, it will be the heritage of our future generations. And they will look back and say, aha, this is what they were building in that period for this reason or another. And English heritage, you're responsible for it now, historic England. So we don't want necessarily to look back and say that whole period was a lack of confidence and people just put, for expedient reasons, they put up fake heritage just so they could get their planning approval and get as much money from the building as possible. Can you please use your imagination? Please show us something that's emblematic of your period that in 50 years, 100 years time will be the new heritage. But it's very difficult to think like that. People have to use a little bit of gray matter. So what tends to happen is that most developers, people with the money who hire the architects, and most architects are under pressure. Please get my planning approval within 6 months, within a year. I don't want to argue with the planners. I don't want to have a fight and spend 2 years doing it. Just do some sort of heritage image and that'll be fine. So it's in that context that we then find ourselves thinking, well, obviously we're not going to just put up this fake heritage. Fake heritage obviously is very expedient for the developer. He can make his money very quickly, but it's one intellectually barren to us, dare I say, debilitating. So you just don't want to do it. You'd rather not do the architecture at all. You'd rather do something else. And given the door is open, historic England have the door open, saying, please use some sort of grey matter to tell us of what this new architecture is. And we as architects have had for the last 250 years exactly constantly the same questions. Where does this new style come from? What style represents us today? Well, the origins, the etymology of all architecture, of all styles, starts with the tectonics, the materials that you use, what Gottfried Semper called the binding and joining of those materials. So Gottfried Semper, at the same time as Karl Marx was expelled from Germany, had to leave Germany after the failed revolutions there, Gottfried Semper also found himself in London, and they were both in the British Museum. Karl Marx in the library, writing Das Kapital. Gottfried Semper, who's an architect, found himself in the British Museum, and the British Museum had just brought in the Assyrian friezes and was displaying them. They were highly popular. And what he noticed was that the stools, the thrones, and the architraves and decoration of buildings represented in the friezes all had similar patterns. And he discovered that actually it's the way the timber on the stools and the thrones were joined and then bound with cloth, as it were, that became knotted and decorative in those knots, that then speaks of how the chair and the stool was put together, but that decoration that became then abstracted in stone and also used as friezes and door surrounds around architraves, etc. He said it's the joining, binding, and he termed it as completion, cultural completion, that derives the motifs, the decoration, the ornamentation of the architecture. He said ultimately all architecture architects have to think of the materials they use, and today we've got more materials than ever. So the opportunities for deciding how one material comes to another, how it's joined and bound, and therefore emblematic of that particular project anyway, if not culturally, is there for us to use. And obviously we're not, on the whole, architects are not trained that way anymore. We're trained to draw first from the skin, the outside two-dimensional skin, as it were, on paper or CAD, inwards, and then have no relationship. We're in a silo of image, where the other silo is the structural engineer, and the two do not necessarily integrate. The engineer is just putting columns of steel or concrete here and there that hold up the free plan of this elevation, whatever free facade of this elevation, whatever we choose it to be. So for us, therefore, is why can't we track a heritage that's much more to do with this joining and binding to complete an architectural language specific to that project or specific to a time if necessary. Sorry, you're meant to be translating, aren't you? Sorry. You're on mute.
Sorry, yeah, I was mute. Yeah, I will have to summarize it. Okay, I am confident that the majority of our audience would understand English, but we want to make sure.
Okay.
But I clearly can see the Zemperian influence when you have basically the heart of your building. There's always something different than the skin, and the skin has this binding and joints that you mentioned. So this division between different building elements is super interesting, and the reference to Gottfried Semper. Let me quickly translate. سوالی که کردم از ایشون این بود که شما توی پروژه هاتون یک صحبتی از فالس هیستوری و فالس مموری میکنید و این تاریخی که میخواین نشون بدین یا این هریتیج به قول خودشون یا این میراث فرهنگی و تاریخ تو پروژه ها و این چیزیه که شهرداری تو لندن ازشون میخواد. در واقع بعد از جنگ جهانی دوم یک دوره‌ای بود که کلا تاریخ فراموش شد و ساختمان‌ها مدرن شدن، ولی در یک دهه 70 عموما به خودشون اومدن خیلی از کشورهای اروپایی که استایل‌های تاریخی داشتن به این فکر کردن که ما چطوری میتونیم دوباره این رو زنده کنیم و نگه داریم، این قطع نشه این رابطه تاریخی، و سعی کردن معمارا رو مجبور کنن که بیان و یک نوعی به هر حال با اون سبک‌های تاریخی ارتباط بگیرن و هر کی به نوع خود به طریق خودش جواب میداد. خیلی از معمارا اومدن و همون سبک‌های تاریخی رو به صورت فیک بازسازی کردن و سعی کردن همون تصویر ساختمان قدیمی رو نشون بدن. کار راحت‌تری هم هست و راحت‌تر هم فروش میره، سریع مجوز میگیره، ولی خب یک دفتر معماری که سعی میکنه تفکر انتقادی داشته باشه اینجوری نگاه نمیکنه به پروژه و سعی میکنه این تاریخ رو باز تعریف کنه و باز تفسیر کنه، چجوری بتونن ساختمان‌های درست کنن که در آینده تبدیل به تاریخ بشه و تبدیل به هریتیج زمان ما بشه. و خب تو این پروژه ها سعی میکنن از جزئیات مثلا ساختمان سازی در طول تاریخ نگاه کنن. اشاره دارم به گاتفرید سنتر وقتی که اومد در انگلیس و تشریح کرد که اون پریمیتیو هاتش یا اون کلبه بدویش چجوری ساخته شده بوده، از چه قطعاتی بوده و اینکه چجوری سعی کردن تفسیر کنن ساختمان تاریخی رو. این پروژه های ایشون هم به طریق همون دنباله تاریخی رو دارن دنبال میکنن و میگن که اتفاقا اون اداره میراث فرهنگی مایل به اینه که تفسیرهای جدید تاریخی ببینه، نه لزوما کپی فیک نماهای قدیمی، و اینکه معمارا بتونن توانایی فکری اینو داشته باشن که اون ارتباط رو با تاریخ معماری برقرار کنن بدون اینکه معماری مبتذل یا فیک درست کنن. Okay, thanks for your patience. Let me go to the questions to see what are they writing. I need to take a look. There is an interesting question. They ask how much of your conceptual/technical thought process do you usually convey to the clients?
Depends on the client. Some clients, we have one client who likes what we do, so they clearly appreciate the ideas and the material methodology, but their priority expressed from the first day is not money. We've got plenty of money. It's time. I want this building to be finished before my 70th birthday. I want to be in there for that and the holidays. When we're developing our various architectural methods and the technical low embodied carbon arguments, we don't orientate those arguments, well, we reorientate those arguments to talk about how much faster the building therefore will be. Yeah. This methodology, pre-making everything with pre-tension beams and floor slabs in the factory, well in advance of them coming in on site, will accelerate the project by 6 or 8 months, and therefore he'll definitely be in by his 70th birthday. Yeah.
Okay.
If I told the engineer this, please do not start talking about the embodied carbon, the fantastical technical innovations we're developing with the stonemasons, because he's interested in time. He'll shout at you. And sure enough, the engineer, I don't know what he was thinking. He must have thought I was joking. He started telling the first thing he came out of his mouth when he met the client was innovation, blah, blah, blah. And the client said, I couldn't care less. Couldn't care less what you're innovating. I couldn't care less about saving the planet. I want to be in by my 70th birthday. If all the other stuff happens but as an aside, then great, good for you. Yeah. So you have to triangulate your argument. the same product just turned through.
Yeah, I understand. It's kind of a sad reality, but let me please translate. سوال این بود که چجوری شما کلا با کارفرما این ایده ها و ایده های کانسپچوال و فنی رو مطرح میکنید، چقدر از اینا رو باهاشون شیر میکنید؟ و جوابشون اینه که بستگی به کارفرماش داره، ولی اغلب کارفرماها خیلی علاقه‌مند به خیلی از این مباحث نیستن. بعضیاشون هستن حتی محدودیت مالی هم ندارن، ولی محدودیت زمانی دارن. میگن من میخوام این ساختمون تا 70 سالگی مثلا تمام شده باشه برم داخلش. ما سعی کردیم تو پروسه کانستراکشن اینو تسریع کنیم، مثلا با پیش تنیدگی تو کارخونه و غیره و غیره. ولی اغلبشون میگن که من خیلی برام مهم نیست که حالا این ساختمون چه تأثیری روی زمین و محیط زیست داره، من میخوام تو این زمان تو 70 سالگی این ساختمون تمام شده باشه برم توش. حالا اگه به عنوان یک نتیجه جانبی از این ساختمون کربن فوتپرینت هم کاهش پیدا کرده بود اشکالی نداره، من خوشحال میشم به هر حال. ولی اصولا ساختمون ما خیلی زمان میبرن و زمان محدودیت اصلی. This takes me to another question that some people might consider your approach a bit too, let's say, romantic, because it takes a lot of time and care, whereas like we see the world is changing very fast. There's a huge need for rapid construction, and we can't spend the same level of detail, in those projects. So what do you think about the future? Do you think there is going to be a small percentage of elite interesting projects with more budget and more time and patience, and then there would be a majority of building mass produced in the companies and factories or corporates? Or do you think there is a way to adapt this method or your approach to a fast-paced, large-scale projects?
Yeah. The last. Well, one, how does this person know how much time we spend on these projects?
We already mentioned the phones arrived in 2011, and it's just.
Oh no! Well, this particular project, Clerkenwell Close, because it's my own project. It was all to do with post-financial collapse, waiting for the banks willing to lend money. So it was done with bank money and not wanting to borrow money at some crazy percentage. And slowly, roughly 2014, they returned to normal rates. So I had to wait for the funding, basically. But we don't have the luxury of spending. We don't have a single client who says spend as long as you like coming up with ideas. So everything we do in the normal constraints that clients expect from architects, and no slower. So we just have to think carefully, because we enjoy it. We enjoy that anyway. So that's it's not a burden to us. It's not a burden to the client. So it's all done in a normal time frame. And certainly our argument is these methods are totally transferable. What we've learned is so we teach as well, and we asked our postgraduate students. I don't know if you want to translate, and I can go on again.
یه توضیحی که میدن، سوال من این بود که شما این روشی که دارین خیلی روش ایدئالی به نظر میاد، ولی زمان و هزینه زیاد میبره و شاید همخوان نباشه با رشد سریع دنیا و نیاز به ساخت و ساز انبوه و زیاد. و آیا شما آینده رو اینجوری می‌بینید که این دو سبک معماری از هم جدا میشن و ما یه سری پرکتیس‌های کوچیک‌تر داریم که کارهای جالب میکنن ولی با زمان و هزینه بیشتر، و بعد یک سری بقیه اغلب کارخونه‌ها ساختمان‌ها توسط کارخونه‌ها و شرکت‌های بزرگ ساخته میشن؟ یا اینکه میتونید در واقع این چیزی که این دانشی که دارید رو منتقل کنید به در مقیاس بزرگتر، ساختمان‌های بزرگتر؟ و جوابشون اینه که ما اصولاً هیچ وقت اینطوری نیست توی پروژه وقت خیلی زیادی داشته باشیم و اغلب پروژه همون وقت محدودی داریم و به این قضیه فکر کردیم که چطوری میتونیم این دانشمون رو در مخصوصا وقتی که آموزش معماری من میدم درس میدم، به این که چجوری میتونیم این دانش رو ترانسفر کنیم، منتقل کنیم به جریان قالب ساختمون که حالا در ادامه توضیح میدم.
We asked some of our postgrad students to look at 7 different archetypes. Normal housing, so the most common type of housing built in this country is detached or semi-detached houses out in the countryside. Mid-rise urban housing, so 5 floors, 6 floors. Towers for housing, towers for offices. So what's that one? The Zaha type cultural centers. Yeah. Airports, the Richard Rogers Madrid Airport. And road bridges, infrastructure projects. Hospitals and laboratories, that was the other one. The challenge was, can any of these be made out of low embodied carbon materials, if not timber, carbon negative, and will they be cheaper? Yeah. And the answer was that all of them. So at the end of that study period, every single archetype could be made carbon negative out of prefabricated bits of stone. If you wish to make them prefabricated to speed up time. And all of them, apart from the bridge, could be cheaper. Now, the reason the bridge could be made of timber and stone, or just stone, or just timber, but actually it's still cheaper to make a concrete box beam end to end as a bridge. So at the moment, road bridges, if you want to make them out of timber box beams, you're going to be cheaper, but it's still carbon positive compared to stone and timber. But the lesson was, anything, if we put our mind to it, any archetype can be cheaper and faster and greener in stone and timber. Problem is, we just don't know that information at the moment. We don't, we're not enough of us know it. Hopefully this talk has transferred some of that information.
Mm-hmm. So the result of those research were some building schemas or design
we took actual buildings that were just being finished, or like the Richard Rogers Airport was finished, I don't know, 10 years ago or something. Mm-hmm. But we took 222 Bishopsgate, the tallest office building in central London. We worked Herzog de Meuron, a residential tower in Canary Wharf. McCrane and Lavington schemes. So what McCrane and Lavington do. It's all very brick London vernacular, 5-story podium with a 14-story tower. Plus Taylor Wimpey houses, Hawkins Brown Hospital in St Thomas's on South Bank. All live schemes, just finished or under construction, and to test, is this possible? And we had a structural engineer, sustainability engineer, and cost consultant work with the students. And we found, all of those are entirely possible to construct today in timber and stone. 1, for making them carbon negative, and 2, for a lower cost. Yeah.
Super interesting. So you translated those structures directly to timber and stone.
Yeah.
Is it published anywhere that we could see or not?
We're going to certainly put it online, because at the moment it's 1,000 pages, which is a bit crazy, because all the students decided to contribute to it. We're going to put it online, but somebody's interested in printing it, in which case it'll be sitting in an RBA bookshop somewhere, or some bookshop somewhere. But keep in touch, and hopefully it's the RCA, the Royal College of Art, and the design unit is called ADS5. So at some point, the work in progress was online when it was work in progress, then it got taken down, and now it's meant to be published for 2022. So hopefully, whether it's via the RCA or somewhere else, it'll be online.
Wonderful. Okay, please let me translate and we can conclude.
Sorry, rambled on a bit there.
Thank you. سوال این بود که در ادامه این سوال که چجوری با مقیاس‌ها و تایپولوژی مختلف میخواین در واقع کار کنید با این روش. گفتن که ما توی همین پروژه تحقیقاتی که با دانشجو داشتیم 6 تا ساختمون تایپولوژی معروف رو، از جمله ساختمون فرودگاه مادرید ریچارد راجر، ساختمون پروژه مسکونی هرزوگ اند مورون توی لندن و پروژه های مسکن ویلایی تا میدرایز و سایزهای مختلف رو سعی کردیم همه اینا رو ترجمه کنیم به مصالح سنگ و چوبی که در موردش صحبت کردم با ظرفیت سازه‌ای که دارن و با اینا بیایم اینا رو بسازیم و تو همه اینا به این هدف رسیدیم که تونستیم کربن فوتپرینت کمتری بگیریم یا رد پای کربن کمتری بگیریم و این در کتابی به زودی چاپ میشه و نتایجش رو میبینید. در نتیجه معتقدن که میشه این دانش رو منتقل کرد به مقیاس بزرگتر و تایپولوژی مختلف ساختمانی. Okay, thank you very much. It was a great pleasure for us to have you, and I think we got inspired a lot and we learned a lot. Maybe you can hang on Zoom so we go off live on Instagram and we can chat for a few minutes. Okay, let me check. Thank you again. Thanks to our audience for bearing with us. Okay, you're off.
Thank you very much.
You're welcome. You're welcome. Nice to meet you all.
Thank you. Thank you. Thank you. It was so impressive.
Thank you.
And
It's not just me, unfortunately. They're not all here, but it's normally the people down there somewhere or other.
At first we judged you why your colleagues went home. You know, after that we saw them.
It's both your residence and your office, right? The same, the clerk and will.
Yeah, exactly. Yeah, that's right. So if you look in that direction, you're right. You can see the exoskeleton up there. Yeah.
What a beautiful office.
Well, thanks. Yeah.
I would love to visit, so I will let you know if.
Absolutely, yeah. No, come around and you can get a tour.
That would be super special. It's kind of when I visited, right after there I visited Sir Johnson's museum.
Oh, yeah.
Kind of resonated with that in my mind and was super interesting. It's still a kind of tradition in London. Super.
Yeah. I'm a trustee of that museum.
Oh wow.
So maybe it's imbued in my mind somehow.
Yeah, maybe. But it's interesting to see that how it's working in contemporary context and in different parts of the world, like that this language is kind of becoming more predominant, and I really enjoy seeing this. Also in Switzerland, we see a lot of different type, of course, but still dealing with this level of detail and construction influencing the form of architecture, because I think it was a period of time over the past few decades that maybe the geometry was very predominant, or the diagram or the deep structure of the building, perhaps with covariant or Colin Rowe approach that we are quite familiar with. And now
it's tricky, isn't it? Because with that discussion we were having at the beginning when we first connected, it's several generations now where we've been grasping for style, and therefore developing theories for it, and to a large degree ignoring the material altogether. And it's not about a binary argument across these. It's just saying, this is why I use the expression of orbiting your mind. You allow all these things just to orbit, and at some point they'll coalesce and make better sense. You could see those the schemes where it's just 3 millimeters of brass. The facade is not attempting to be tectonic. It's got nothing to do with structure, is it? In fact, it's exactly the opposite. It's to sort of suggest an illusion of permanence and structure. And as you get closer, this thing is actually floating off the floor. It's a skin, and the structure is behind doing something completely, something very simple and pragmatic. So I don't. It's not that I want to be dismissive of the last, say, several generations. It's more that I think there's the struggle that's been slightly blind a blind struggle that Semper and others try to open up. The irony of Semper is that he was actually working at the Crystal Palace on pavilions of different Commonwealth nations, empire nations, yeah. And that was informing his theory as well, especially about the difference between what they call Kunstform and Kernform, so the structure and the skin. But he's also asking, what is the architecture of the future? What is the architecture of modernism? Yeah. So the modern period, for everybody, people forget, is the period of the Enlightenment, and Schinkel and others who were all neoclassical were then towards the end of their lives, and then certainly into the 19th century with Semper and others, Ruskin and Morris. What is the language of the modern period? And it took all the way to the Bauhaus for us to form a language. And the irony is that Semper's standing in the Crystal Palace, and it's being made out of bits of metal and glass, and this whole thing is just metal and glass, several stories tall with several internal layers, that then becomes the offices and the shopping malls and all the rest of it that we know today. But he couldn't see it. He didn't understand that this was the future that was coming. These new materials that he talks about, the joining and binding becoming emblematic of a period, are actually already happening all around him. And it took another generation all the way to the Bauhaus modern movement to then say this is the material, the architecture that's emblematic of our time. And that search, grasping search, I think is equally, there's still a struggle there, because we tend to miseducate or par-educate architects. So we were discussing earlier, architects used to be masons. So you took a young apprentice at the age of whatever, 14, 15, and you made them an apprentice for 7 years, starting off in the quarry, starting off with bits of timber. And after 7 years, they will submit their masterpiece and graduate as a master mason. And they will have knowledge of the materials themselves, what type of stone, how you cut it, how you set it, how you combine it with timber, stuff that's been passed to them from other master masons. So they're engineer. They know their materials, and they combine that with architecture. It's all one thing, yeah, including its symbolism and its motifs. And because we've removed that knowledge, intimate knowledge of material and structure, and we just educate mostly in drawing and the meaning of that representation, that draw representation, we're forever going to be struggling with, well, what's it made of? Why can't it be made of anything? And what's the new language and style therefore? Because it's not born from any material consideration, structural / material consideration. That's not to say stone, if we start playing with stone and timber again, we're going to end up with the architecture of several hundred years ago, because we can cut it different ways. We can pre and post tension it. I don't know if do you know A.A. Nastas? Bear with me. I'm going to try and share with you.
Where are they?
They're based in Paris, but they're also in the I think they're in the West Bank. They're sort of French national Palestinians. Bear with me. Thanks. So they're
Nasta Studio.
That's yeah, you found it.
Found some image, some collage like.
Well, do you want to share it? I'll find out if it's. So they're amongst a bunch of other architects who are interested in the classic parametric designs, and how that you just take that software and you've got fantastic routing tools now that can cut 3-dimensionally any piece of stone, and they've ended up. Yeah, that's not. That looks all a bit. Oh, I see. Nastas. No, bear with me. If you unshare that, or if I will find them. If you bear, we had.
There's also Mark Foster Gage in here. All that he does.
Anastas. Here we go. AAU. And then Anastas is ANASTAS. And if you bear with me, I'm trying to find, well, actually, why don't I just share the images?
Oh yeah, I know them. They were in Venice, right?
Yeah, I think they've been all over the place. But if you, I mean, can you see all these images? I mean, you know, this one, for instance, this is what they call, there was a French engineer during the 17th century who postulated that you could make a reciprocally loaded ceiling, small pieces of stone, if they're cut and resting on one another and the next one's resting on the other, it could be flat, and therefore you don't need big bits of timber or big bits of stone. And somebody actually built that about 100 odd years later. But here they're using software to say, okay, fine, it's all reciprocally loaded. And each one of those pieces of stone is one small piece of stone, but that they've taken their software and made it also a series of parabolic arches. Yeah. So this is just a sort of hypothetical idea that they've actually built.
You know, Azadi Tower in Tehran. It's the national monument, Azadi Tower in Tehran.
Yeah.
Which is also the same parabolic shape made out of stone. And back then it was built like 40, 50 years ago, and they didn't have computers. So they sent it to London where they had the software to design these three-dimensionally curved stone pieces and build it. It's just, this reminded me of that.
Well, it's, if you look at that, that is again trying to create everything in stone there. Yeah. So it's a smaller model of what they're going to build. So here's the flat one. I think this is in somewhere or other on the West Bank. And then I think the underside of it looks like that. Yeah. So they're having some fun with it. Yeah. So there's nothing to say that you're going to end up with an architecture that looks like it's 200 odd years old. You know, you've got modern software, modern tooling techniques, and all these things are just going to improve more and more. Engineering software that will help you optimize how thick and thin that stone can be, how it behaves in seismic zones and all the rest of it. So there's nothing stopping us, just our lack of imagination, I guess. Yeah, so our argument is use it because it's abundant. Yeah, you know, people say, oh, you're going to run out of stone. Well, you know, the Earth's mantle is stone. The day we run out of stone is the day that we're sitting in magma. Yeah, so it's there. All we're doing is removing one bit of stone from the mantle, putting it elsewhere. It's abundant. And people say, oh, well, you know, the Earth will be covered in quarries. Well, guess what? Well, currently we quarry limestone to make cement. So that same quarry, we take out one piece of limestone, we crush it, we burn energy to crush it into small powder, then burn it at 1,600 degrees centigrade to turn it into lime that's then mixed with other chemicals. Then we have to get sharp sand from another quarry. We have to get aggregate, and then we mix it together with water and we create a cement block. Oh dear, the cement block now only has 40% of the strength of the original limestone block. I know what, I'll put some steel in there to reinforce it and make it stronger. So, put like that, it's clearly illogical and absurd. Now, obviously, concrete has its places. So again, I'm not going into a binary argument of never use concrete again, never use stone again, steel again. It's about having an intelligent, stepping back and having an intelligent idea about, will it be better? One, is it cheaper? Is it embodied carbon is less? If I use stone and timber instead of steel and concrete.
Mm-hmm. This is invaluable for us, especially in Iran. We have a lot of stone resources, but we are very poor in terms of timber. So this is something that maybe we can rely on more in the future.
Yeah. Well, I mean, look, stone has got an embodied carbon of 49 kilos of carbon dioxide equivalent per cubic meter, and that it starts off as 0. And that is only because if you're using diesel machinery to cut it out of the quarry, diesel vehicles to put it on the back of a truck and then ship it truck it to the center of town to build whatever it is. So if you lower the cutting machinery, the embodied carbon of that cutting machine and transportation, it'll come down lower and lower. Steel is 1,800 kilograms per cubic meter. Concrete with reinforcement is 550, so 10 times the amount. So the reason stone is still expensive in some parts of the world is because, well, yeah, we've only got, a couple of quarries and a couple of guys, and it'll be expensive to extract it, and we've got a monopoly. So what you want to do is just mass produce it in the same way as mass producing anything brings the price down. It's no longer a luxury product; it's just a standard commodity of which we make stuff.
Yeah, I think that's the challenge, to make it industrial, mass produce it, because it is, you have less control on it, right? Like compared to concrete, it's hard to test it. You don't know if there is a crack in it, how to pre-tension this. So it has a lot of problems. Even in Iran, when sometimes we talk with structural engineers, and instead of beam and column system, we ask them to do shear roll. They're like, no, that's too much trouble. Just let's do regular.
No, it's the same here. And our structural engineer is quite honest. He says, look, every structural school of engineering in this country, no one teaches stone, because there are no experts. All the teachers have graduated in steel and concrete. Their papers are funded by the steel and concrete industry to keep researching into those materials. No one is paying them to research into stone, so they're having to self-learn. And you're quite right. Most structural engineers are going, oh dear, oh, what do I do? But in France, because they've been doing this, they never stopped. Each quarry owner will look at the bed, take extracts from the bed, and say, okay, the strength, send it for testing, and he'll tell you that part of the bed has this strength or that strength or that strength. So depending on what you want to use it for, take the stone from this part or the other part of the quarry. And then you would test that stone again anyway. The structural engineer would test that stone and say, fine. So you take a sample in the same way that you take steel samples and cement samples, slump tests and all the rest of it. You would do the same for stone.
Interesting. Okay, thank you so much for your time. It's just invaluable to us in Iran, and I'm sure a lot of people just listened and they enjoyed. So best of luck for you and group work, and we are really looking forward to seeing what's happening in the future with your projects. Best of luck.